a bunch of tests in Solidity, then Foundry is probably better. But in this case, I'm just going to deploy a simple app. So I just went with hard hat, but it doesn't. Either one is just as good. I think hard hat is catching up to Foundry in terms of speed, but Foundry is faster right now and great for, like I said, writing your tests in Solidity. But I just went with hard hat today, but it was just a random decision. It could have been either one. So we're going to let this install, and it will take a little bit. Definitely there will be time for Q&A, but if you have questions along the way, just like shout them out, and I can repeat them and try to answer them. So feel free to just shout questions out. This should be like very open-ended. I'm going to go through building something with the tooling and just kind of show off both writing the smart contract and the front end, and then deploying the app to a chain. We're waiting for it to install right now, though. And actually, while it's waiting for that, I could pull up Cursor or VS Code, whatever your preference is. I kind of like Cursor because I can throw some prompts at it, and it'll do a little AI stuff for me here and there. Let's see. Okay. Let's see. I want to CD into Devcon app. Nope, not demo app. Done this a few times before. Devcon. There we go. And I'm going to do, so after you clone down the repo, you get this list of commands you need to run. So we're going to do a yarn chain, and that's going to spin up our local blockchain. And then we'll do a yarn start, and that will bring up our front end. And then we'll do, over in this terminal here, whoops, we'll do a yarn deploy. And that's going to deploy our example smart contract to our local chain. Oh, CD, Devcon app. Yarn deploy. Let's see if this works. Okay, so this is kind of the starting point. You have your code up here. Oops, Devcon app. You have your code here, and you kind of have scaffold ETH over here. And let's get right into the smart contract. So here is our smart contract. Scaffold ETH comes with a kind of example smart contract that has a handful of different concepts already built into it. Primitives and data types, you've got events, modifiers, constructors, all the good stuff here is kind of just an example smart contract for you to quickly just kind of tinker around with Solidity. But it's a greeter contract, right? Classic greeter, we can set the string, and looks like there's some extra logic here, keeping track of how many times, and maybe this is an interesting thing here. If you send in money, it's going to set some premium flag to true, right? So let's go test that out. Let's go play around with it. So if I go to localhost, our web app should come up here. And what I'm going to do is just dink around with this set greeting first, just to make sure it's working the way we think it is. Okay, so here's our app. This is how it comes out of the box. And I'm going to jump over to this debug contracts tab. And that is where you can really kind of iterate and see your contract and kind of poke at it. So there was this set greeting. Let's say hello world. This is going to complain that I don't have gas, but that's okay. Let's hit it and let's see what it says. It says, oh, you don't have any gas. So Scaffold ETH uses burner wallets. When you're working local, when you're doing local dev, it's a lot easier to just use a burner wallet rather than have like MetaMask and have to set the chain ID and have all those problems that come along with that. So you'll see here, I just have a burner wallet here. This is just an address that's generated. And to show that off, if I just open up localhost, I get another address. See that? There's a new address there. Let's do that one more time. Let's just open an incognito window and go to our app, and you'll see I get a new address every time because of that incognito window, because it's stored in local storage. So Bad idea to have burner wallets in production, great idea to have burner wallets for dev, because you can quickly just kind of like hit buttons here and make transactions happen without having to have the MetaMask prompt come up. So right here is a faucet. That's the second thing I need. So I've got my burner wallet here, and I'm going to hit this button, and it's going to give me some ETH. So now I have ETH for gas. Now let's try this set greeting one more time and see if this works. There we go, hello world. So we were able to, let's say hello world 2. Let's try it again. We're able to send a transaction, and that's going to update the greeting in our smart contract. And let's go try that premium thing. Let's go look at that one more time. Right here, it says if there's value, it flips this premium flag to true, whatever that is. So let's send in some value. And you'll notice I can't do 0.001, right? I can't just send that amount of ETH. It's a decimal. You have to multiply it times 10 to the 18. And so Scaffold ETH has that little button over there that takes it times 10 to the 18. Now, of course, you wouldn't want your users to have to type in, 0.001 and then hit the times 10 to the 18. This is very much built for a developer, and it's meant to kind of expose to you what's happening kind of underneath the abstraction. But I need to hit that button to take it to way, and then let's see what happens. All right, hello. Let's say hello world 3 even. In value now, you can see that there's money that's getting collected in the contract, and that premium flag got set to true. So this is kind of like the core game loop you want to get in with Scaffold ETH, is you want to have your smart contract up over here, and then your front end up over here, and as you add things to your smart contract, your front end will auto-adapt to it. So let's just go add something here. Let's say maybe we want to make a mapping, balances, that looks good. So for any given address, there's UNT 256, so there's balances. And then let's make a function called transfer, right? And hopefully just the AI writes this for me and I don't have to do anything. But basically, we made a mapping that keeps track of balances for any given user, and then we have a function that allows us to transfer that balance. And let's deploy it and go to the yarn deploy. We'll get some more stuff over here. There we go. So now we have balances here. Let's check my balance. It's going to be 0, right? Yeah, I'm gonna need an initial balance. So let's copy our address and let's go back to the constructor. And let's set this dude's balance. So we'll say balances of this address and trying it out. So what we want to do is say, hey, do we have a balance for this address? We do, okay. And then if we wanted to transfer, let's send one to Vitalik, right? You'll notice this does ENS resolution. It has a nice ENS avatar. This is something that you get out of the box with Scaffold ETH. It's made for building apps. So it has all of these components that you'll use to build your app quicker. So let's send one to Vitalik. Here we go. Uh-oh. Actually, it's 1,000 way, right? So I should not have done this thing. I should just do 1. There we go. Yeah, I didn't have the balance to send to him. And then if I go check my balance again, it should be 999, right? Okay, so we're kind of in this loop where we're able to write some Solidity and tinker around with it in the front end and try things out. So let's think of an app to build. Let's say we wanted to make like a really, really silly prediction market. We might need an address that we would call the oracle. Okay. We're going to say address public. Oh, man. And I'm going to call this the oracle. And I'm going to set that to, I don't know, this dude's address, I guess. I don't really know what I'm doing right now. I'm just kind of tinkering around, trying to figure out what I want to do. And then let's say there's like maybe 3 possible outcomes in our prediction market, and I want people to be able to buy into any given one of those things. So let's see, maybe we have like a function called like purchase, I don't know. And then let's do like a uint 256, maybe we'll call it index. And it will be payable. Hey, that's pretty good. Let's see what this is. No, I don't think we quite want that. Let's see. What we want to do is keep track of how much someone has paid into this. So it's payable. Yeah, so let's see. Let's do this. Let's see, how should we do this? Maybe like an enum. Let's do it like this. Let's do a mapping for an address to a number, and then actually I want another mapping inside of that maybe. Maybe this is too complicated. Maybe I should do something simpler. Maybe I shouldn't build a prediction market. Maybe we just, let's just sell some things. How about that? How about we let someone buy a thing in our contract and we trigger an event for it or something like that. Maybe they purchase an item and the index is that item. And so we might want to emit an event here. Maybe we want to trigger some other action. Let's get rid of this oracle. Let's just go with purchase and let people buy something, and we'll trigger an event and we'll let them send in money. But I don't know, maybe there's like 5 or 6 different items and they're buying those items. Maybe we want to require, how about we'll require that they send at least 0.001 ether or something like that. Must send at least, there we go. Okay, and then, maybe we, increase, let's see, balances. Yeah, maybe let's do a mapping and we'll have an address to account, and this would be like items bought. I don't know. We're just kind of dinking around here, playing around. So we'll keep track of a mapping of items bought, and so then when someone goes to purchase this item, we will set items bought message.sender plus equals 1. And I don't know. I don't know what else we'll do. But it's up to you. You guys are the Solidity devs. It's up to you to really write this logic in. You can build whatever you want. I'm just kind of showing an example app here. So I guess we let people purchase something and we keep track of the items bought. Let's go play around with it and see if it works. So let's go ahead and deploy this. And let's go see if we can buy some items from our contract. Uh-oh, what did I do here? Balances, right? Yeah, get rid of this. Kind of like the prediction market idea. I should have prepared it a little bit better. But for now, we'll just have a little store that lets people buy things. So let's try that out. So we've got this purchase function now that lets people put in an index. We'll have that in the front end. So let's say you're going to buy item 3, and you're going to need to send in 0.001. And let's see if this works. There we go. So it did work. I was able to trigger the transaction, and the money went into the smart contract. But now it's got me thinking, what happens if that money gets locked in that smart contract? I should probably set up some kind of like owner. And it looks like there is an owner already here. Looks like it's passed in through the constructor. Let's go look at that. It's the deployer. Let's set us up as the owner. Okay. And let's redeploy it and see how that looks. What I want to do is make sure I don't have money locked in the contract. I want to be able to withdraw the money, I guess. So if we were to put this on a live network, we wouldn't want a bunch of money to get trapped inside the contract. So let's see, we're going to buy item 2 for 0.001, and let's hit send. And the money goes into the contract, but now the question is, can we withdraw that money back out? And I'm going to, there's a withdraw function here. Let's go look at that in the code real quick. It was built into the contract before. It looks like it checks to see if you're the owner, and if you are, it sends you the balance of the contract. That's perfect. Let's try it and see if it works. So we have, what, like $3 in the contract, and then we hit withdraw, and hopefully the money's gone. Okay, cool. So you'll spend a lot of time in this loop where you're tinkering with your Solidity, you're in the front end, poking at your contract, you're adding new things to your contract, kind of like what I was doing there where I was like, oh, I'm going to make a prediction market. Okay, now I'm just going to make some items that you buy. Like, you're still kind of playing around, but Scaffold ETH lets you get in this rhythm where you can make a small change in your solidity and then go tinker with it in your front end with this nice auto-adapting front end. But let's say we're pretty happy with it, right? Let's say that we like the way our little store works here, and we are going to now maybe work on the front end a little bit, okay? So what is it? It's not happy about this. Oh, you know what we should do? We should maybe emit an event, right? Emit, yeah, something like that. And then let's throw that event in here. Yeah, there we go. Nice. And then, yeah, the index is there. It's still not happy about that, is it? Let's see. Let's see if this works. As long as it compiles, I'm happy. Okay, so now we have an event that is emitted when we buy things, but let's go try to buy, you know, item number 1 for 0.001. Let's try this, make sure this works. Okay, cool. So you'll spend more time on your smart contract, but let's say that I've spent weeks or at least days working on my smart contract, getting it right. Really, I'm just kind of tinkering around, so I have this simple little bit of code. But you'll take more time. You'll spend more time on this. You'll get it working. You'll probably want to even write a bunch of tests for it and stuff. But let's say we're happy with it. Let's say the smart contract basically does what we want it to do. Let's now move on to building the front end and have some React talk to our smart contract. So the front end will be over, let's see, we probably want to, let's just have like a couple of buy buttons and a thing that says how many you've purchased or something like that, right? That'd be a very simple front end. So if we get out of Hardhat and get into Next.js, we can find our app here. And this is this page. So if I go to home there, this will take me to this front page here. So what I want to do is kind of clear this stuff out and prepare for adding some code. Let's see, let's clear all of this out. Whoa. Let's see, down to about here. How's that look? There we go, okay. And so then instead of welcome to Scaffold ETH, we'll be like, welcome to my cool crypto store or something like that, right? All right. Oh, I spelled it wrong. C-R-Y-P-T-O. There we go. All right. My cool crypto store is ready for business. Now, you'll see that we're using WAGMI for the use account. I can get rid of some of this stuff. And so the WAGMI docs are always really nice. If you need to look anything up, we can just go look that stuff up. Right now, for instance, we're using use account, right? We could go look that up and see how that works. But what it's doing is giving us basically the logged in user here. The connected address is what we're renaming it to, and then we're displaying it here, and that's what creates this nice thing right here. And so just to dive into that a little bit more, look at how this address looks. If we were to take this address component out and just have the raw address right in our front end, it's going to look super ugly, but let's do it just to do it, just to see it. Okay, connected address, if I hit save, oh, no. There we go, yeah, that's what I want. There we go. So now we have like this really ugly address, right? And you don't want to display an address like this in your front end for your users. You'll want to have that nice address component wrapped around it. Let's do that again. I think I can just undo a couple times just to see the difference between this, okay? So instead of just displaying the raw address, we're going to pass it into this nice component. And when I hit save here, then we get this nice looking component that has the block key or the ENS avatar, the nice little copy button. And then if I click this, it's going to take me to the block explorer. So right now we're on localhost, so it's just the localhost block explorer. But if you were on a live network and you clicked that address, it would take you to that address on the block explorer, whatever network you're on. Okay, so let's set up our store, right? I'm guessing we probably want to have some like buy button, and then we probably want to like read how many items we've purchased or something. So to do that, let's go look at the Scaffold ETH docs. Normally, I would probably already be just like prompting Cursor to write this for me, but I think it's a good practice to show y'all how it works. So instead of prompting the AI, I will actually just like build this thing. Okay, so what I'm looking for is the, let's see, interacting with your smart contract. And I want to specifically do use scaffold read contract, right? So this is how we're going to read from our contract. I'm just going to copy this code exactly and paste it into my front end. If I can grab a hold of it. There we go. Okay, and we're going to put it with our other hooks here. Okay, and we're going to import it. Okay, and so this is really nice because anytime you make a change to your smart contract, those artifacts are automatically injected into your front end. So watch this. If I go to this function name and I do open quotes, it's going to give me a suggestion for all the different items that are in my smart contract. This is really nice. And I can go here and say, you know, total, what, like items bought, I think is what we're looking at. Okay, and then that's going to come back here. And let's see, does that take in, what does that smart contract look like? Items bought takes in an address, right? So we'll need to have our address here, and we'll say this is the connected address, right? So hopefully, with just this line of code right here, basically what we're doing is we're going to our smart contract and we're reading how many items we've bought, and we're storing it in this object right here. So let's go maybe down here. Let's see, maybe we'll make a new div. Hopefully I don't have to center it. Okay, let's say items bought, something like that. And then that, and I think I need to do a toString here. I think I've done this a few times before and had that mess up. But let's look and see what we have here. Probably one, okay? There's one item bought. It's really funny that that's not centered, and I was joking about centering a div, but I'm not gonna go center it. It's gonna stay like that. And let's go purchase like item 5 for 0.001. Make sure that counter goes up, right? Make sure we're correctly reading the state. Oops, big int, right? You need to hit that button. Okay, so let's go back and look here. Now our items bought is 2, okay? So it's keeping track of how many items we bought, and it's putting that in the front end. So we're successfully reading from our contract. Now we want to write to our contract. And to do that, I'm going to go to use scaffold write contract. And we'll bring this in here. And we'll import it. And then we'll grab this button, which is exactly what we need. It's for setting the greeting, so we'll have to do something a little different, but we're getting close. Maybe we'll set up another div here and then throw this in here. And then you can see, oh boy, I don't think I got all of it. Make sure I get all of that. And then paste that in here. Please work. Okay, there we go. So this is a button, and when you click it, let's see, we're going to say buy hat, okay? Yeah, this will be for a hat, and so that will be index 1 maybe, right? And what's the function we need to call? we can do that same thing where we open up the quotes and it goes and looks at our contract and gives us that purchase function. And what does that purchase just takes the index, right? So we're just going to say hats are index 1 for some reason. Why is it not? Oh, maybe it needs to be a big int. Okay, and then value here, we're going to have to send in some money, right? 0, 0, 1, whatever we want to end up charging for this. And import parse ether from VM. All right, let's look and see what we have so far. How is our app looking? So if I hit buy hat, what's going to happen here? Hey, pretty cool. Yeah, item spot goes up, and the hat, and this increments, right? So maybe let's then copy a couple of these buttons. Oops. Okay, so buy shoes. Whoops. Okay, and maybe that is even more expensive. I don't know. And this will be item 2, for instance. Okay, let's go look and see how that looks. So now I can buy hat, and notice like there's no MetaMask pop-up because we're using those burner wallets, but eventually like we'll have MetaMask and we'll have all that stuff there. So let's see if this works. Uh-oh, what did I do? So I think it needs to be exactly 0.001, doesn't it? Let's try that. Okay, cool. So we have our cool crypto store, we have the items that we've bought so far, and then buttons that allow us to buy more items, right? Very simple, stupid app. You're the builders here. You guys can be creative. You can write some good Solidity. You can build the front end. All I'm trying to do here is just show you how Scaffold ETH can help you build this thing very quickly. So we've got our store basically working. It's super ugly, but it's pretty good. So now I think the next step would be to try to deploy this. So let's see. I've got plenty of time. I could definitely like make this a little bit more advanced, but maybe not. Maybe let's just get this thing all the way out into production and try it out first. Oh, you know what I need is a withdraw, right? I need to make sure that this withdraw works. But I can always just come into the debug and do it, so I think I'm happy with that. Yeah, let's just go with that. Ooh, maybe events. How about we list events? That's a good thing to do here. Let's go to, event history, and I'm gonna grab this. And I'll throw it in up here. Okay, and what is our event name? Item purchased, cool. So we're gonna listen to your contract, item purchased. I don't really need much of this stuff, definitely don't need that. I don't think I need any of this stuff. Let's see what happens. So we should get some events here, and then if I wanted to list those events, let's just like output them in a really ugly way here. Oh, hey, how about that? Oh, thank you. Let's see what that looks like. Uh-oh. Oh, I need to import use scaffold event history. So I'll import that there. There we go, items bought. We definitely don't see our events though. What do we need to do to be able to see our events? Event transaction hash, what is this? I don't even know. Let's do something like just like a pre and just like spit the event out. Huh, I mean that looks, all right, let's go to console log. I don't know what it's doing. Let's see what this event, well, I don't even really care about this key, to be honest. Let's see. Oh man, it's freaking out. Yeah, let's get rid of that. So let's just have this div, and let's have, let's see what things we have on this event. Dot args dot buyer. Yeah? Let's see. It is not liking this. What do I have wrong here? Yeah, okay, no events. I'm scratching it for now. Let's get this thing built and deployed. I'll come back to the events if I have time later. Let's get our store deployed. That's the key here. Okay, how's that looking? Do we have the store? Can I buy a hat? Can I buy some shoes? Does the items go up? Does the contract hold the money? It looks like it is. Looks like it's all working still. Okay, so now, whoa. Let's deploy this thing. Let's put it all the way out into production. So there's going to be two parts of that, right? We need to both deploy our smart contract and deploy our front end. So that will take multiple steps here. I'm going to venture into the yarn generate real quick. This is something new to Scaffold ETH. I hope this works. I might have to do some weird stuff here. Let's see if it does. Okay, cool. So to deploy an app, I'm going to need a deployer account. I can't just use the zero account on Hardhat or whatever. I'm going to have to actually create an account and fund it. And that's what this does here. It is yarn generate created my account for me, and then I'll do a yarn account, and that's just going to show my deployer account. Okay, and then I'm going to send some money to that. What network should we deploy to? Base, okay? Anybody? I'm gonna go to base. Here we go. So I'm going to put like $1 worth of base into this deployer account. Okay. $1. I'm going to use a Punk wallet, punkwallet.io. It's built with Scaffold ETH 1. Okay, so now we have our smart contract ready to go, and I just sent a few bucks to this deployer account. So now I'm going to do a yarn deploy dash. Okay, so yarn deploy is what I've been doing this whole time, right? If I hit yarn deploy, it's just going to deploy it locally. But if you do yarn deploy dash network and then pick whatever network you want to deploy to, let's go to base. Okay, so hopefully this will deploy our smart contract to base, like a live network. We're going to spend real money and we're going to deploy a real smart contract to a live network with lots of time left. I could make a much more advanced app if we have time. Okay, so I think our app is deployed now, but we still need to do that front end part. We need to set the app to the right network, and you do that right in here. There's a scaffold config file. And this is really handy. This is where you set up all your configurations for different things within your app. And we're just going to change this chain to base. And if I hit save, now come look at our app. You'll notice that the burner wallet went away, and now we have to connect, and we'll use MetaMask. Okay, and I'll connect that. Ooh, I'm not the owner though. We should redeploy this with my MetaMask as the owner so I can withdraw the money. I'm going to do that. So over in my deploy script, it's setting who the owner is right here. I want this dude to be the owner instead. And let's redeploy our contract. And that means that my address will be able to withdraw. It was set to the burner wallet before, and I don't want the burner wallet to be the owner, because then I would have to have burner wallets in production, and you'd rather not. Okay, now let's check this out. So if I go to debug, who is the owner? Okay, I'm the owner, great. And if I were to purchase an item, like a hat, this is a real transaction now. I'm spending real money. I'm putting money, I'm loading $3 up in this contract. Yes, I want to proceed. Bro. Okay, there we go. So we just made our first transaction on our smart contract, and let's see if our items bot goes up, and hopefully it does. And also, hopefully, yeah, I can see that I just executed on a contract too. It's pretty cool when it's a live public network. Items bot is now 1. Fantastic. Okay, let's buy another hat real quick, just to load the contract up some more. Okay, make sure that works, make sure items bot goes up again, and then what we want to do is go make sure we can withdraw the funds back out of the contract. Let's go do that next. So if I go to debug contract, I can kind of like go poke at my contract here, and what I want to do is make sure I can withdraw this $6. So let's make sure the $6 comes back out to me when I hit this withdraw button. So we're watching this money here and this money here to make sure that that works. Yep, got our money back. Okay, cool. So our app, our smart contract is already deployed to base, but our app is still on localhost. Like I said, there's kind of like 2 pieces to deploying this. You need to deploy your smart contract and your front end. So to deploy the front end, I'm going to yarn Vercel YOLO prod. This is my favorite command. And what that does is just like it ignores like type safety and stuff is what that YOLO prod stuff does. I think there's some kind of like checks and stuff, and I just don't want to even deal with that. Okay, so let's see. Now, sure. No. No. It's called Devcon app. Okay. And it's located there. And no, we don't need to modify anything. Okay, so now it's deploying. So we've tinkered with our smart contract where we could set it up so we have the smart contract here, right? We had our smart contract here, and we had this nice debug page. And this was like our initial game loop, right? We wanted to tinker with our smart contract. We wanted to build our smart contract. We weren't quite sure what we wanted yet, but we could kind of like add things into our smart contract and then come over here and kind of feel how they work, right? We can kind of see the things here, we can poke at them and try them, test our assumptions. That was kind of phase 1, was building out this smart contract with this feedback of the debug tab. And then phase 2 was kind of moving into the front end and writing some buttons and some read and write functions, right? That was kind of phase 2. And then phase 3 was deploying the smart contract and the app, and that is on its way to be deployed, but we're waiting on it for a little bit. So there's quite a bit I could do to show off more scaffold ETH stuff, but let me just kind of like pause there and open it up for questions, and maybe those questions will take us down some other rabbit hole. Yeah, go ahead. So you're saying like when I hit buy hat, it immediately updates. There's really small block times on base. So it's not like Ethereum where you make a transaction and you have to wait 15 seconds for that to finish. Like the transactions are happening immediately because they're going to like a central sequencer. Does that make sense? It's just an L2. It's just faster, cheaper L2. On ETH, it would take 15 seconds. I would hit buy hat, and it would wait. You'd have to wait for that block to get validated, basically. So it'd be like a 15-second time between when I hit confirm here and when it actually like lands on chain.
And so like The scaffold, whoa. So in a case where it takes, like on another chain, like longer, scaffold ETH is like pinging the chain at all times to get the info.
Yeah, that's what that read function is like constantly reading and looking for changes. Let's look at that right here. The items bot, right?
Yeah.
All we said is go to your contract and read items bot for this address. And from then on, this items bot item is up to date with whatever is on chain.
Okay, thanks.
Does that make sense?
Yeah.
Yeah, cool. More questions? Anybody have any more questions about what we've done so far, about how it works, reading and writing to the contract? Anything else? Might just have to build. Oh, here we go. We got a question.
Okay, thank you very much. I've learned many things. But as I was wondering whether I can choose the account to use for deployment. Because when you wanted to deploy the smart contract, you generated an account and sent some Ethers to this account before deploying.
Yes.
So is it possible for me to set the account which I want to use to deploy?
So that is a good question. So I just generated an account, and this is what I like to do, is I like to have an isolated deployer account that is just for this deployment. So I don't want to use another address from somewhere else. I want to create an address just for deploying this contract and put just enough money in it. So it's kind of like a one-time use account. But technically, you could like set some other deployer account in here. The way I'm doing Yarn generate and Yarn account is it's kind of handling the address for me, but I could get in here and like change the private key if I wanted to, I think. Does that make sense? But you really don't want to do that. It's best not to do that. It's best to have a nice isolated account that you put just enough money in and deploy with it. Does that make sense?
Okay, thank you.
Yep.
I have a second question. Yes, for the front end, so you deploy the smart contract on the blockchain, which is a decentralized platform. But for the front end, you want to deploy it on Vercel. So are there solutions to deploy the front end on a platform which is also decentralized?
That is also a great question. And I think that it's kind of an elephant in the room when we look at like decentralized apps and they all just like live on Vercel or something. You can, I think, export this. You could do like a static build and upload it to like IPFS or something like that. It's just not something we have like, I don't know, if I do a Yarn IPFS, does this work? It used to back in the day. I don't think it does though. Is Carlos and crew here? I don't know if the Sand Garden's here. No, I don't see him. Yes, I think the short answer to that is you could make a static build of your website and upload it to like IPFS or to other services, but it's okay if it's in Vercel because it's open source and really forkable. So if someone wanted to redeploy this somewhere else, they should just be able to fork my code and bring the front end up in Vercel or whatever they want. But good question though, like Vercel is centralized for sure. And so if you're trying to build a decentralized app, you need to make it in a way where people can spin up their own front ends or fork your front end and bring it up on any service. But we just deployed to Vercel for this.
Okay, thank you very much.
Yep, good questions. Okay, let's see where our deployment is. Did I do the Yarn Vercel? Did that go? Maybe that already happened up here. Let's see if our thing deployed. Yeah, here it is. Okay. Hey, there it is. Okay. So, if you wanted to go buy something from my store, you totally could right now. I could share this URL with you. And of course, I would want to shorten the URL and make it look nice. But I don't know, in about 20 minutes, we were able to tinker with our smart contract. We were able to deploy it to base, and then we were able to deploy our front end to a live URL. And let's go buy some stuff from our store real quick. Okay, let's do a buy hat. Let's see what happens here. Yeah, spend some money, $3. Okay, and now this is at a live URL. So this app is decentralized as far as Base is decentralized and Vercel is decentralized. Someone could definitely like fork this and bring up their own front end on localhost. So, but it is in Vercel, and we were able to buy a hat and buy some shoes from our store, and we're making transactions and they're working. And then maybe we should go sweep that account and empty the contract. Let's go do that next. So let's go look at our contract. Has like $10 in it now. And if we withdraw that, let's see what happens. Please work. Man, that's annoying. I don't know what I'm doing, why it's... Okay, now we're watching to see if this money comes out of here. And if successful, then we built our first decentralized store and deployed it all the way live and sold some shoes and hats, and then we withdrew our money, and it worked. So I was able to buy the items, I have the buttons, I could even like send this URL to you guys could navigate to this, and you could buy hats and shoes also. More questions. Anybody have any questions about Scaffold ETH? I'll be doing a, yes, please.
I saw it briefly show the built-in, I saw it briefly show the built-in block explorer.
Yes.
I think it's pretty awesome. If somebody was using, say they wrote their own tests against localhost, could they use the block explorer, or would that work? Like if they weren't using Scaffold ETH, if they had some pre-written unit tests but wanted to sort of take a peek into the transactions?
Possibly, yeah. So let's go, well, now when I click this, it's not going to go to the Block Explorer, it's going to go to the base Block Explorer, but let's go put the app back on localhost, and then we can look at that. So let's go to, yeah, we just barely touched on that Block Explorer. Let's go look at it. So what I need to do is go to my scaffold config, and I need to, let's set this back to hard hat and hit save. And then our app is going to, just by doing that one change, our app should go back to localhost. Oh, I'm at the live URL. There we go. Here, okay. And it's going to have me switch networks. This is really nice. By the way, if a user comes in and she's on the wrong network, you need to bump them over to the right network. And so Scaffold ETH is going to handle that too. Notice this nice switch. But let's go look at that Block Explorer again. So yeah, I guess that's for that address. What else can we see here? This would be all the transactions here, right? And I can click in and see, you know, there's a purchase of 0.001. Someone called the purchase function. So yes, I think that to answer your question, you could use this Block Explorer to do some local inspection on things. I'm not sure if it was exactly the question, but hopefully that answers it. Like, yeah,
I think
go ahead.
so. I've just been in situations where I've wished for a local host Block Explorer.
Yeah, yeah. What you can do, so Block Scout is also another one. You could go get Block Scout. It's an open source Block Explorer, and you could run that also. Like bring up a Docker container next to it, and it would also work. But yeah, this is kind of rough, but it would work. It would do what you want, I think. It would kind of tell you, you can kind of see all the transactions there that are happening.
Cool.
Okay, so our store is up. We put it on base. Kind of just to recap, sort of like phase one is editing the smart contract and playing with it in this debug tab. So you'll get Scaffold ETH downloaded, you'll tinker with your Solidity, and you'll kind of play with it here, getting it written correctly. Maybe, do I want to use arrays? Do I want to use structs? Like, how do I want to build this thing? That's kind of like phase 1 is tinkering with your smart contract, testing your assumptions, poking at it with this debug side. Then phase 2 was that front end, right? We had to do the read contracts, we had to do the write contracts, and to do that, I just jumped into the docs and kind of copy pasted them. You wrote the Block Explorer, right? Yes. Yeah. that's port. So phase 2 was kind of that front end where I was putting in buttons and reading and writing from the smart contract, and I just used the docs here to copy paste how to read from a contract, how to write to a contract, and that was kind of phase 2, getting my front end going. And then phase 3 was deployment, right? We deployed the smart contract, we deployed the app, and now they're all live talking to each other. And you can do this anytime you want by just going to scaffoldeth.io, and you can clone down the repo, or you can do this npx create ETH. Okay, more questions? Any more questions? Yes, sir.
If you would want to integrate more common building blocks, maybe like chain link functions or like a graph or something, is there anything we have to pay special attention to, or would it just work out of the box?
That's a great question. So the short answer to that is there is an external contracts file right here. And so whatever contract you wanted to talk to, like in this case we have DAI on mainnet, what you would do is whatever contract you wanted to talk to, you would put that in here, and then you can just talk to it with the read and write functions from Scaffold ETH. So let me see, like chain link functions. I don't think I could put that in right now, but yeah, I think the short answer there is if you want to go talk to an external contract, there's this external contracts file here in Next.js. And you can use that to list out the contract you want to talk to, and then the read and writes from Scaffold ETH would work the same. Does that sort of answer that question? You may even possibly have multiple contracts here. You might inherit from another contract or something like that, but yeah, the things to look out for would be, I don't know, you need to be on the right network. Just have that contract in your external contracts and then start talking to it normally. More questions about Scaffold ETH, about building on ETH, about what we did today? Any other questions? Maybe I could go back and work on that event page for a little bit. I kind of did the speed run. It was a little bit too fast, but let's see here. Let's see if we can get this history going. I kind of want to dink with that, see if I can get it working.
Sorry, they have one question.
Yes, please. Where
Over
are
there.
Yeah, is there anything that lists the full stack that Scaffold ETH uses?
Yeah, it's here on the website. So Next.js, RainbowKit, WAGMI, TypeScript. Anything in particular you're looking for, or?
Just wondering if there's a list of all the different tools that are floating in there. I see there's a difference between Foundry and Hardhat. I don't know if the differences between them or anything like that.
So yeah, at the beginning when we did that npx create ETH, it gave me the choice Foundry or Hardhat, and you basically can choose. And Scaffold ETH kind of keeps that abstraction above, so when you do yarn deploy, it's going to deploy whether you're using Hardhat or Foundry, and it kind of takes, abstracts that away, so it's easier for you. You just do yarn deploy whether you're using one or the other.
Is there anything else to know with Vercel just popped in as well? Anything else on the side?
It's hard to be able to think about all the things you might need to know.
Well, that's included in Scaffold. I mean.
Yeah, Scaffold ETH comes with either Hardhat or Foundry for your orchestration, and then Next.js for your app. and within that, we have Rainbow Kit, WAGMI, TypeScript. Cool? Yeah. More questions? Any other questions? Yes?
Is this available for React Native?
I think there is a Scaffold ETH React Native.
Yeah, I've tried that, but I couldn't get it to work.
React
It's
Native?
probably me, but-
Yeah, I don't know. We had one a long time ago, but I don't know if we still have it.
Okay.
A good way to find these things is to go to the Build Guild, like our actual app here, and then go look at builds. Maybe we could even search this native. Let's see what comes up here. Yeah, Scaffold ETH React Native. You said you've already tried that one and it didn't work?
Yeah, but it was probably, was doing something
Yeah, it's
wrong probably. Yeah.
pretty old, yeah. Yeah, because this is, you have to like reinvent a lot of things here.
Yeah, isn't this like the first version of Scaffold? or
Yeah, this is like an older version of Scaffold ETH too. Yeah, so I don't think we have an up-to-date React
Yeah, no
Native
worries.
version. Yeah.
Thanks.
Any more questions? So later today, I will be doing a similar talk, but I'm going to go through building your first 5 apps. So let me just introduce that before I take off here. It's Speedrun Ethereum. So if you haven't heard of Speedrun Ethereum is a curriculum that will help you learn how to build on Ethereum by having to actually build a bunch of things. It'll take you through building a simple NFT, a decentralized staking app, a token vendor, a dice game, a DEX. So this will take you through and have you build the thing, and it won't let you just copy paste. You'll have to like think for yourself and actually build the thing. And so this is a really good way to learn how to build things by just building a bunch of things. And I'll be going over each one of these in more detail this afternoon. I don't know what time that is, later today. But yeah, so Build Guild is the DAO that's kind of around all of this stuff. That's how we're funded. We're funded through the Ethereum Foundation, and we work on tooling like Scaffold ETH. Let's look at the extension system too. So when we did that npx create ETH command, here, let me show this. When we ran this command, there's an option to do a -e, which would be an extension, and that lets you bring in a lot of other tooling. So for example, let's go look at, yeah, here we go, on-chain kit. So here is an on-chain kit extension. So let's even just like copy this. I'm just gonna create a new folder and run this again. Let's see. Oops, I don't want to do that. Yeah, okay. So it's npx create ETH, latest, and then we have this -e on-chain kit. And so what this is going to do is it's going to use this on-chain kit extension and bring in the on-chain kit stuff along with Scaffold ETH. And this is really handy. You can build, oh no. Oh no. Uh-oh. Ooh, that's not good. Let's try another extension. Let's see if one of these other ones works. I think something's broken with, yeah, say you wanted to do subgraph. You'll look for Kevin Jones. He'll be doing a talk not tomorrow, but the next day, and he'll do something with the graph where he does some indexing. Let's see if all of this fails or, uh-oh. Well, we're gonna have to fix that. Something is definitely wrong here where the extensions aren't loading in. I'm not sure what that problem is. But the extension system is really nice because you can bring in some extra components. For instance, you could bring in, like we were looking at on-chain kit there, right? So you could bring in some of bases, like their smart contract wallet, their swap component, their token selector. You can kind of just like with one line, when this is working, I'll need to fix it. I don't know what's broken right now, but with one line, you can basically install scaffold ETH and these extra extensions, and it's just going to speed up your process of building even more. But I can't show off extensions because it's broken right now. I will have to figure that out. Okay, so to recap, Scaffold ETH is a great tool for prototyping, but also easy to deploy to production. We saw today, in only like 20 minutes, I was able to write the smart contract, test it out a little bit, build a front end that talks to the smart contract, and then deploy that whole thing both to Base and also to Vercel. And so you should be able to do this at home also. Just go to scaffoldeth.io and you can get started today. And then Speedrun Ethereum is a good way to kind of double click on that and go a little bit deeper and learn about more concepts by actually building some things. That might be all that I have. Any more questions? Definitely open to questions. I'm Austin Griffith on Twitter. I'm this dude. Oh man, internet is slow. Oh no. Maybe that's what this is, or maybe it's just like the internet's. Nah. What's that? Oh, really? The MPX-E is? Do I need to make a directory or something? Let me see. Let's do test and then cd into test. Oh, I wanted to show that I was this dude. This guy, Austin Griffith. Yeah. I can't do it right now. I don't know what's wrong. Okay, anyways. Let's see. And then let's run that again. Nope, I don't know. I don't know what it's doing. It could be. Oh, it's telling me that there's rate limits? Yikes. On GitHub, is that what it is? Oh yeah. Wild. Okay. That is a new one. We'll have to look at that one. I'll pass that on to the Scaffold ETH team. Yeah, okay. So in recap, Scaffold ETH 2, great tool for both debugging and also shipping apps. It's a great way for you to tinker and kind of figure things out as you go. Once you have Scaffold ETH and you figured that out, go to Speedrun Ethereum and take on these challenges. There's a bunch of things to build here, and that's going to teach you a lot of things. And then at the Build Guild, as you go through Speedrun Ethereum, we even have like onboarding batches and small grants available. And I think that's it. I'm very open to questions, though, if you guys have any more questions. I'm 20 minutes early, but the app, it was quick. It deployed fast. Yeah. Oh, thank you. We do have time to kill if anybody has any questions. Just leave it open out there. Shout them out if you have them.
I'll kill some time.
What do you got? What do you got?
So, what's the kind of... Oh, thanks. I sound loud enough already, right?
Yeah.
Hi. Oh, that's too loud.
For the online person.
Hey. Yeah, so when you fork from Scaffold ETH and you make your own apps, obviously there's going to be improvements released to Scaffold ETH. So how easy is it to benefit from those improvements if you fork the project? There's a lot of the improvements, are they like scoped into dedicated libraries and stuff like that?
That's a great question, and it sets me up to talk about our extension system.
Let's go.
Yeah. So going back to that extension system that wasn't working right now because it's rate limited, the point is you can have, so an extension is basically just some solidity and some front end. And the solidity and the front end aren't probably going to change that much, but you're right. Like if a new version of WAGMI comes out, you'd like to have that new version in your app. So with the extension system, you basically build an extension out of your stuff, and then it stays state of the art. Whatever new stuff comes in from Scaffold ETH just comes in. You could fork it, but then you have to like keep that merged downwind, down chain, down whatever it is, downstream. I think that was what I was going for. Yeah. So I guess the answer is yes, you will have to keep merging new changes to scaffold ETH if you end up forking it. And there are, improvements that happen regularly that you would probably want to pull down. But the best way to do it is to make it an extension and then have just the latest scaffold ETH at all times and just your smart contract and your front end injected into that latest version. Any other questions? Yeah.
Suppose they wanted to use scaffold ETH against like a hard hat fork of, say, Base. Is that?
Yeah. Let's go. So instead of so here's my blockchain right here, right? If I kill that, oh no, my screen's not there. That's okay. So you just do a yarn fork. The too long didn't read there is instead of yarn deploy, or instead of yarn chain, which is what we use to bring up our chain, you do a yarn fork. And that's going to fork mainnet or Base or whatever. You have to supply like what network you want to fork, but yes, that's not going to work. But yarn fork is the answer, yeah. And Foundry works a lot better, I think, than Hard Hat at that. It's a lot faster. Any other closing questions? Thank you guys for coming out and checking out Scaffold ETH. Make sure to hit up scaffoldeth.io. Make sure to hit up speedrunethereum.com. Tell your friends if they're looking to get into building on chain to go speedrun Ethereum. And keep your eyes out for the Build Guild and the stuff that we're building. Any final questions?
What are you working on right now?
Oh. That's a good question. I think that we as the Build Guild want to do better medium to hard curriculum. Speedrun Ethereum is a good start, but it really doesn't quite prepare you for building your own protocol, for instance. And so what we would like to do is create some medium to hard curriculum that gets you closer to mainstream apps and building your own protocol. And I think that looks like a handful of different things. We've got Elliot working on the ETH Dev tech tree, which is a really cool kind of tech tree that's built out. That's kind of an offshoot of this. If you go all the way to the bottom of buildguild.com, there's a tech tree here, and it's like this really gross Miro board of mine. But it takes you through all these different concepts and kind of like the tech tree of all the different concepts behind like tokenization and DeFi and all of that stuff. So this is kind of what we're working on right now. It's just medium to hard content. We've got the tech tree. We have a CTF, Capture the Flag, that we'll be playing tomorrow. Keep an eye out for Build Guild. We're going to have a morning session where I do something similar that I did here, and then an afternoon session where we'll play the Capture the Flag, and you'll take on some challenges from the Build Guild. And a third thing, I think, in terms of medium to hard content and what we're working on, there's like this idea that's brewing in the back of my head that's kind of like this agent-based game, where it's like you have to build a Dutch auction, and there's like hundreds of agents, and they want to use your smart contract, and it's all just like localhost and for fun, but it helps you get a feeling for what a live protocol might be like, and having lots of users use it, even though it's just localhost and fun. But I think somewhere in the cross-section of the ETH Dev tech tree, our CTF, and this like agent-based idea, hopefully we converge on a good medium to hard curriculum and kind of extend. We're not going to call it the speedrun, because the speedrun is kind of like beginner. We're going to call it something else. Maybe ETH Dev tech tree is what we go with, but it'll be its own meme, but something along those lines. Medium to hard, get people prepared to like build their own protocols. Yes, sir.
Why is it misspelled?
Yeah, okay, that's a great question. It's misspelled? So it's like going back to the old like hodl meme, right? Like back in the day with Bitcoin, someone would say hold or hodl, and then someone from the ETH space kind of reframed it to Biddle, and so we thought it was a cool name, and we went with Biddle Giddle, but I just say Build Guild. But yeah, it's a play on that old HODL meme from crypto. Yep.
Can we use a...
I'll restate the question, maybe.
I want to ask, 80 minutes is still very long. 80 minutes is still very long time. Can we reduce to 10 minutes with ChatGPT?
Oh yes, yes. ChatGPT is way better. Let's just go do that real quick, just to show that. So let's say we were like on the front end, right? And we had those buttons. Let me just clean this out real quick. Yes. With Cursor and ChatGPT, it's so smooth. But let's say, let's go down here. Let's just tell it to add another button, right? Add another button for buy coats or something like that, right? Let's see what it does. Okay, and then I just hit apply and save, and now hopefully our app can have a buy coats button too there. So yes, it's way faster with ChatGPT. Oh, yes,
How
sir.
is testing, unit testing?
Yes, so that will rely on either Hard Hat or Foundry, depending on which one you want. Foundry would be your tests are in Solidity, Hard Hat would be tests in TypeScript, but there is just like a test folder here that has like an example test in it, right here. And so, yeah, so here's the test right here. And then you can run that by doing yarn test. Oh, maybe not. Nope, it is not yarn test. Maybe I need to Hard Hat test. Oh, I'm in the wrong one, yep. Let's go to that Devcon folder. Yarn test. Yeah, there we go. So then it runs your tests for you. Yeah, so it relies on either Hard Hat or Foundry, depending on what you use. But again, it kind of abstracts it away to just yarn test. Cool. Cool? Yeah. Only 11 minutes left. Yeah. Oh, you want to look at the test? Yeah. You're saying this test here, right? Yeah. Is that code big enough? So yeah, let's see what it's doing. So it's gonna set up the signers and get the contract ready. It deploys it, and then it's gonna expect that some certain thing. So you should be able to set the greeting, right? So we do a set greeting here, or maybe we're just getting the greeting and we're expecting it to be that string. So when we deploy it, it should have that as the string. So it's basically just checking that the greeting is correct. And then here it is setting the greeting and then checking that it's set correctly. All right, last chance for questions. If you have any more questions. You got one? You got a spicy one? Let's go.
So why do you have Hard Hat as the default option? Because I would kind of consider it sort of, not deprecated, but kind of legacy.
True. So to defend the Hard Hat dudes, yes, they are, like Foundry has kind of
big respect to them, by the way.
Yes.
Like, it's great tech, but I just mean, I feel like Foundry is so much more popular now.
Yep, I agree. And I think that the Hard Hat dudes are speeding up. Like I think they're even using Revum now underneath, so they're using some of the Foundry stuff. And I think that Hard Hat is a little bit better for deploying contracts, but the short answer is, when we built Scaffold ETH, we used Hard Hat at first, and we're now transitioning to Foundry, and it will be Foundry by default very soon. No, not that spicy.
I guess not.
Yeah. Anything else? All right, thank you. Go speedrun Ethereum. Go use Scaffold ETH and go build something cool. Thanks a lot. What's that?
See you in the afternoon.
It worked, yeah. Thank you. some small things with that. And then we're going to go through Speedrun Ethereum, and we're going to kind of just like look at this curriculum and kind of talk through each of the like learning moments that you'll go through when you go through Speedrun Ethereum. So let's get started with Scaffold ETH first. Scaffold ETH is a dApp developer tool. It's great for tinkering with your smart contracts, and it has this auto-adapting front end that is really nice when you're tinkering around with your smart contracts. So I'm going to run this. Devcon 2. This will be my second demo today. Maybe we'll do Foundry this time. So Scaffold ETH is a dApp building tool, like I said. It uses Next.js, RainbowKit, WAGMI, TypeScript, and you kind of have the choice between Hardhat or Foundry. It's a great tool for prototyping. You can quickly get something out the door. I think I deployed an app in like 20 minutes, and we had lots of time left for questions. So I'll do the same thing probably now. It'll probably go pretty fast, but let's let this thing install, and then we'll go tinker with Scaffold ETH. Devcon 2. Okay. Bringing the code up here. It's still installing, so we've got some time. But let's go look in here. You kind of have these two main packages. There's either Foundry or Hardhat. That's kind of like your backend. That's your orchestration tool. That's your deploying and testing. And then Next.js is your front end. Scaffold ETH does some really nice things where when you compile in Foundry, it injects those artifacts into your app. And we'll see that in a little bit, but it's really nice when you're working on your front end and it knows about all your smart contracts and all the variables, and you can it'll auto-suggest how to fill in stuff. I see a couple of people that were in my last talk. Sorry, this will be a refresher for like 10 minutes here, and then we'll get into Speedrun Ethereum. Okay, so let's see, is our app up here? We're gonna go look at our contract, and it's a basic contract. Has a lot of initial concepts that are here, like primitives and data types and events and constructors, but it's a greeter. It's a greeter contract, and let's fire everything up. So we'll do a yarn chain to bring up, well, let's CDN first, Devcon 2. And then we'll do a yarn chain, and that will spin up our local blockchain, and that's what we'll deploy to. And then I'm going to do a yarn start, and that will bring up our front end. And it's the two things kind of working in symphony that is kind of the magic sauce of Scaffold ETH. And then we can yarn deploy here. And what that is going to do is ship your contract to the local chain. Compile and deploy. There we go. Okay. So we're compiling and we're deploying, and kind of the heart of Scaffold ETH is that you can have your app up here, and you can have your code up here, and you can make small changes to the code, and you're going to see those changes reflected in the front end. So if we go over to the Debug Contracts tab, again, sorry for the repeat for people who are at the last one, but it's good to run through the concept here. Let's look at the greeter contract real quick. What do we have here? So there's a greeting, and it gets set. You send in a string, and it gets set. So let's just do that real quick. It's gonna yell at me for not having gas. When I hit this, it's gonna say something like, oh, wait, we're still connected. Let's get out of here. We want burner wallets. Okay, so I just disconnected my MetaMask, and the first concept here is burner wallets. You'll use these in dev rather than in production. you don't usually use burner wallets in production very often, but they're really nice in dev because you can just like hit a button here and it sends a transaction without having to have the dialogues come up and have your chain ID right and all of that in MetaMask. It's telling me I don't have any gas, but if we click this little faucet button here, now we have some ETH. And let's see if we can set hello world. Yep, there we go. So now we see hello world there, right? And that was from this thing here. And like I did in the last demo, I always like to look at this little premium flag and dink around with this. So there's this piece of code here that says if they send in some value, then we set premium to true. There's some flag called premium. And so let's just send in some ETH. And also, there's no decimals. You need to convert it to way by multiplying times 10 to the 18, and there's a little button to do that. Of course, you don't want your users to have to do that. This is something that you'll do, and this is like a developer kind of thing. But in the front end, you would just do this behind the scenes. Okay, there we go. So it's true now. We were able to send in some money, and now there's money in the contract, and we're able to set the greeting and have that little premium flag set, okay? So debug tab, like this is really nice because now I can go and I can add some code, right? What if we wanted to make an address public, I already have owner. What will this be? Beneficiary? Beneficiary. And we'll set that equal to some other address. Let's just set it to this address. Oops. Oh man, I don't know what I did there. Copy this. Okay, paste it in. There we go. Okay, and when I hit save and deploy this now, watch what happens. We're gonna get a new beneficiary over here. Oops, deploy. So I'm watching for that to show up here. And sure enough, there it is. There's the beneficiary. So notice how that just auto-adapted. Like all I did was add a line to my contract for beneficiary and deploy it, and then my front end recognized that new variable and displays it here. So you can really kind of tinker with stuff and play around with however you want your smart contract to work and kind of test your assumptions. Let's see, let's do this. Let's test some assumptions here. So there is this withdraw function down here that lets us pull the ETH out of the contract, and it's checking is owner. I'm gonna take that is owner off of there, and I'm gonna write a different require statement. I'm gonna require that the message.sender, the person calling the function, has to be equal to the beneficiary, or it'll say not the beneficiary. So instead of the owner, we're gonna have this beneficiary that can do this withdraw. So what I wanna do here is I want to try to test this. I wanna see how this works and test my assumptions and make sure this works the way I think it does. So the way I would do that is I need to sort of withdraw as the beneficiary, and then I'll kind of try to withdraw as a bad guy, and it should not work as the bad guy, and it should work as the beneficiary. So let's do that. Let's try that out real quick. Okay, so now let's set the greeting real quick and send in some money, just so there's money in the contract. Okay, so now there's a couple bucks sitting in the contract, right? And then let's call withdraw, but let's call withdraw as a bad guy. So to create a new account, you can do this really quickly by just opening up an incognito window and going to localhost. Notice I got an address here, kind of C2, C4. Now if I close this and do it again, new incognito window, I'm gonna get another new address there, okay? So let's grab some faucet funds and let's go over here and let's try to withdraw this $3.39. Hopefully it yells at me and says something like, not the beneficiary, very nice. And real quick, let's see if this dude can withdraw. It should. Let's find out. Did I click it? There we go. and the money's out of the contract, okay? So like I said, testing your assumptions, right? Like I made this line of code that said only the beneficiary can call this withdraw function. And then to test it, I basically tried as the beneficiary and then tried as another account and proved that it only works for the beneficiary and not for the other one. Now, that's not exhaustive testing, of course. You would want to write a more extensive test suite eventually. But for just dinking around, trying things, trying to figure out how you want your smart contract to work, this is a really kind of quick way to iterate and try things. Okay, so scaffold ETH is great for this kind of prototyping that we're doing here. Then eventually you'll move over to your front end and you'll write some React. I'm not going to do that. I already did that earlier. We'll do that tomorrow. And yeah, let me show that real quick. So tomorrow, like all day long, we're going to have a Build Guild community-led session. I'm not even sure where it is. Where, like that way? Do you know where the CLS is? Oh, it's upstairs. Okay, cool. So we'll have a big room and we'll do intro to building on Ethereum in the morning. And then in the afternoon, we're going to have a capture the flag. So it's going to be a challenging challenge. It's going to be a challenging challenge. But the guys at Build Guild have built like 12 different challenges, starting from easy, and they get harder and harder. So come by the community-led session tomorrow. Just look for Build Guild. We'll probably be upstairs. Okay, so Scaffold ETH is kind of the underlying tool here, but what I'm really going to show off mostly is Speedrun Ethereum today, and we'll go through each one of these challenges. But let's see, have we basically covered most of the Scaffold ETH stuff? Let me see if there's anything else I want to talk about here with Scaffold ETH. Probably aren't going to deploy any contracts. I think the front end will be taken care of for us. I think we're good. I think we've tinkered enough with Scaffold ETH. Let's go ahead and start working on Speedrun Ethereum. Like I said, the underlying technology here is Scaffold ETH, but this is a nice curriculum that'll take you slowly through building your first 5 apps on Ethereum, starting with just like a simple NFT app. So what you'll do here is you'll deploy an NFT smart contract. So you'll go through these settings, you bring up the chain, you deploy, you'll have a front end, gas and wallets. We've kind of already covered this, but we're using burner wallets. You'll go to the faucet to get some funds. Yeah, again, we're using burner wallets, not MetaMask. So you're just kind of like learning burner wallets here first. And I think maybe even you send around some ETH here and you use the faucet to fill up your account. And there's no code in this first challenge. This first challenge is just about kind of calibrating your the tooling and getting used to how Scaffold ETH works. But you'll go to the My NFTs tab and you'll hit this mint item button. And that mint item will mint you an NFT. And you can get in and look at the smart contract and see how that all works. Maybe we'll run through some of these in a little bit, but let me just kind of cover, maybe we should just run through it. Why not? We got lots of time. We'll go through this slower tomorrow if you want to follow along, but I'm gonna just go ahead and clone it down. Might as well go through the first challenge here. Ooh, I already have it there, huh? Simple NFT 2, all right. Oh boy, that might be too slow. Okay, well, let's just follow along here. Maybe that'll come down eventually. Oh yeah, it did, okay. What do we do, a yarn install? Oh, here, let me just follow the instructions, even better. Okay. So we CD'd in. Ooh, I need to git check out the simple NFT branch. Then I yarn install. Okay. I'm going to close the rest of this stuff from the old terminal. We don't need any of those anymore. Okay, and we'll do the same thing that we do with scaffold ETH, where we bring up yarn chain, and that's going to run our local chain, and then we'll do a yarn deploy, and that will deploy our smart contract to the chain. Oh, whoa, sorry. Okay, and then we'll do yarn chain. We did yarn chain, now we'll do yarn deploy. And that should deploy our smart contract to our blockchain. And then we'll do a yarn start, and that'll bring up our front end, and it will look familiar. It should be very, very familiar to Scaffold ETH, because it is. Okay, so here it comes. Let's see, we're gonna have our app up at localhost 3000. There we go. Here is our app. Here is the burner wallet stuff. We can hit this button to fund our wallet. Let's see, what does it have us do? It has us go through and get some gas. Is it sending? Yeah, I think, oh, I see, this is just the faucet. We can skip this. I would recommend on your own time going through Speedrun Ethereum and going through each one of these challenges. I'm gonna kind of like briefly go through them, but I'm probably not gonna go slow enough that you'll get everything from it. So I would recommend like going home and going through Speedrun Ethereum at home sometime. Okay, but let's see what we have. So it's gonna tell us to, what, mint some things? Let's do it. Let's go to my NFTs. And let's hit mint. What's going to happen here? Yay, there's our first NFT. Let's mint another one. Okay? And I think the directions say to send them around. Yeah. Okay, so we're going to create an incognito window, right? So we have a second account. And we'll go to localhost. And you'll notice there's kind of like this kind of red and teal guy, and then there's kind of like this green dude here. So we're going to try to send the buffalo to the green dude. I think I can do my NFTs here. Okay. Let's try to send an NFT to this dude. So I'm going to copy his address. Then I'm going to go here to, let's send him the buffalo. I need to put in an address, so paste that in. Now, hopefully, this fires off a transaction and sends the buffalo. Yeah, all right, he got it, okay? So that's most of the first challenge, I think, is basically just, like I said, kind of calibrating your tooling and getting ready. You don't really have to actually write any Solidity, but let's go look at the smart contract real quick just to see it. See what the NFT contract looks like. Okay, and if we go to packages again, and you either have Hardhat or Foundry, and then you have Next.js. If we wanted to look at that contract, your collectible is what it's called. Notice we import a bunch of things from OpenZeppelin to make that 721 work, ownable and counters, and then we inherit all of those things. And you can see there's sort of like a base URL. So what happens is it stores a base URL for the NFT, and then it puts the NFT in IPFS and then puts the hash of it in the smart contract. And here's the mint item, pretty straightforward. We're minting something, incrementing the counter, some before transfer hooks. But that's it. There's the token URI right there. Let's go actually debug that and look at that token URI real quick. So if I go to here and I go to debug, and let's see, what can we do? We can get our balance. Whoops, didn't mean to disconnect. I'll take the burner back, please. There we go. So we could check our balance. Let's see what it is. It's 1, right? We own one of them. And then if we maybe look at who the owner of token ID 1 is, it's that other dude. Token ID 2 is us, okay? And then let's get the token URI. So if I say I would like the URI for token 2, it's going to give me this IPFS link. And if I follow that, it should be a description about the NFT and an external link to the zebra. There it is, very nice, okay. So that lives in IPFS, and then this stuff is also in IPFS, but it's kind of like a manifest, and then the hash of that goes on chain and lives kind of right here. It's kind of hard to see, but it's this QMV thing. It's that right there. That's the unique identifier of the content. Okay, so let's see. Is that basically challenge one? Let's see what else we need to do. We minted it, we sent it around. Oh, okay. So what it's going to have us do now would be deploy the thing to Sepolia. So instead of deploying locally, we would deploy to a public network and then probably do the same thing where we send it around. I'm going to skip this, I think, just because it's going to be the same thing. It's just nice to have it on a public network, and that's how the auto grading works. When you're doing this at home, you'll hit this submit challenge at the end, and you'll put in your deployed URL wherever the Vercel site is that you create, and you'll put in the link to your contract on Etherscan, and we have an auto grading system that will then go through and grade your challenges and let you know if you got it right or not. And so each one of these challenges you turn in, and then the auto grader grades it. But I'm not going to turn this in, and I'm probably not going to ship this even to Sepolia, but it's right here in the directions, pretty easy to do. Ooh, even contract verification, very cool. What you can do is verify the contract, so then when people see it on the test network, or when they see it on the Block Explorer, they can actually see your code, which is really nice. Okay, let's call it. Let's say this is good. Let's move on to the next challenge and really start looking at some code or looking at an actual challenge. I think this first challenge was just like basically spinning things up and sending them around. But the decentralized staking app, you will have to write some code. So this challenge is about building a smart contract that allows people who don't trust each other or adversarial parties to coordinate. In this case, they're coordinating to a group funding effort. Basically, maybe you need to buy, let's just say you need to buy something for $500 and you need to get 5 of us all together to put in $100. But the thing is, we don't trust each other, and we can't, and it's important that you can't get griefed, basically, or locked up, right? If someone can figure out how to lock your money or steal your money, that's really bad. So you want to build the smart contract in a way that everyone stakes in, or everyone puts in their money, and if you get enough together, then it will go into a different state, basically, like a successful state. But if you don't get enough money together by the deadline, you need to figure out how to put it into like a withdraw state, so then people can withdraw and get their money back. And so you have to just like think of all these different possibilities for how this could play out if people don't coordinate. But the cool thing is, all they have to trust is the code in the smart contract. They don't have to trust any other players. All the players have to play by the rules of the smart contract. And this is kind of like hopefully starting to show the kinds of things that you might build on Ethereum. The NFT is kind of like a simple collectible, and honestly, like, NFTs are more like passports, right? Like your passport or your digital credentials. I feel like the digitally scarce art thing wasn't as cool as we thought it was when we did it. I think NFTs are a little overhyped. Okay, so what we're gonna do, or what you would do if you were going through this at home, is you would build a staker.sol, okay? So what you're gonna do is build this smart contract that allows everyone to stake, and we're going to keep track of everyone's balances, and then after some deadline, we need to have at least some threshold of ETH stored in the contract, and if it's And then after the threshold passes, you call complete, and then that checks to see how much is staked. And if there's enough staked over the threshold, then you put it into like a successful state. And what it does is it just calls some external contract and like buys something with the ETH. But if there's something wrong, maybe you didn't get enough money together, then you want all your users to be able to call withdraw and get their money back, right? Okay, and it will have a nice little front end for you. And yeah, let's go for it. Let's clone it. So there's kind of this interesting thing that you learn when you're going through this, and it's that contracts aren't automatic. You always have to like make a transaction to make something happen. So when we're thinking of the state machine as we're in the staking phase, and then we're either in the success phase or the failure phase, to move from one of those phases to the other, someone's got to click the button. Someone's got to pay to make the transaction work, right? And this kind of brings up the idea of a Web3 cron job. In the Web 2 world, when you want to run a cron job, oh man, what's this thing called? Here we go. In the Web 2 world, you might want to run a cron job to, say, roll your logs or something like that. Like every night we want to, roll a log, or I don't know. In the Web 3 world, we might want to do something like compound interest every night, right? So you're not going to just run a service that checks in to compound your interest or something like that, because if that machine falls over, then the whole system doesn't work. You're only as strong as your weakest link, sort of. And so if you have a really hard and strong blockchain, and then you have this like service that's calling it, and that falls over and everything breaks, then it's no good, right? So what you need to do is you need to create a system where you write the rules correctly. You say anyone's allowed to check in at once every 24 hours. Anyone can check in once, and you write the rules so that happens. And then the key here is that you incentivize someone to hit the button, and that's a good like aha moment when you're building these smart contracts. Basically, you write the rules to say that someone can only check in once, and then you make sure they get paid for checking in. And that's the key. That causes this system where then you can share this code and anyone can run it, and at least one person is going to run it because they're financially incentivized to do so. And so if you want an automatic task to run on Ethereum, you don't just run a computer that does it. You have to write the rules correctly and build incentives around those rules to get folks to behave the way you want them to. Okay, let's see what we got here. Yarn install. Yarn, oh, I think I need to check out, oof. Yep, and then I did that. Let's see. Let's just remove this, then try it again. Yes, then yarn install. Oh man. Oh man, I can't type. Here we go. Okay, now we're installing. All right, so challenge 1 is about building this staking app. And it's gonna operate like a state machine, as I've explained. We'll let people stake money, and then at some deadline, we'll check and see if we've reached the threshold or not. Okay, and let's go ahead and deploy our contract. And we'll run a yarn start right here. I don't know, I think maybe the chain is not running. Oh, wow. Okay, we've got a couple chains running here. This is, this is kind of a mess. Let me clean this up a little bit. Okay, there we go. So then we'll do a yarn chain to bring up our chain, and a yarn start to bring up our front end. And let's go look at it. Okay, and this is the old one. I'm going to close that out. Okay, so here is the front end for the Staker app. There's some staking UI that lets people stake 0.5 Ether and then either withdraw or execute. And then we see all the events here. And just like Scaffold ETH, you have this nice debug contracts page. Let's go ahead and deploy our contract. Let me just follow the instructions here. Is that what's next? Yep, that's what's next. There we go. Okay, yarn deploy, here it goes. There we go. So now our contract is here. Let's see what we have. But there's no code written yet. I think we need to write some code to get this to work. Whoa. Okay. So let's see. Let's edit the staker.sol. Yep. Okay. Yes. Okay. So this is where it's like you're going to need to know by this time you're going to need to know some Solidity syntax. You're going to need to be able to write your own Solidity. It's not going to let you just copy paste the values in. You actually have to like learn. Like you have to know what you're doing. You have to like think for yourself and actually build the thing. So let's see what we need to do here. It's telling us we need to edit the staker.sol, and that's the old one. Let's bring up, all right, let's use cursor this time. Okay, and then let's go look at our smart contract. Here it is. Okay, so this external contract is just an example contract, and it's to know that you've completed this, it just like sets this bool to true. So don't worry about that contract. We'll call it from the staker contract. Okay, and then, all right, so it looks like there's some scaffolding here. There's some comments about what you're supposed to do, but basically the code is not written yet. It does instantiate that smart contract, and one of the things you're learning here, there's like a handful of different kind of learning moments here, but contract to contract interaction is kind of a key thing here, and that's what's going on. We'll have this staker contract instantiate this contract, and then it actually calls it right here. So right here, it's actually calling that function. Nope. Right here, it's creating the contract, or it's creating the instantiation of it, and then later on, we'll call some function on it. Okay, so what do we need to do? It says you'll need to track individual balances. I guess we can copy paste this, right? So we want to keep track of balances. And what else? And we have some constant threshold. Okay. So we're keeping track of all the money that anybody puts in, and then we have this threshold where we need at least 1 Ether in the contract to be successful. Okay? All right, now it's time to write our stake function, and we're going to test it with the Debug Contracts tab. So what do we need to do here? Let's see, does it give you any other hints? Not really. We've got the threshold. Okay, so what should the stake function do, right? We should, let's just look at this first goal here. We should see the balance of the staker go up, right? So let's do that. Let's create a function called stake, and it's payable. Ooh, we've already got, look at that, it's just gonna fill it in. I don't even know if that's right. Let's see, no event. Does it want me to, oh yeah, here are the events here, yep. Oh. Huh. Oh, here it is, yeah, okay, there's this event right here. Oh, it already did it. Okay, so I just need to create the event here. Event stake. There we go. So we define the event here, and then we emit the event here. So someone calls the stake function with some amount of money. It's a payable function, so people can send ETH in, and we increment their balance based on however much money they send in, and we emit an event. Let's go test this. Let's go deploy just this contract, and let's go try to stake some money in and see if our balances show up. Okay? So I'm just going to use the debug contracts tab for now. Ooh, where is our staking function? Okay, something's not right. Did I not save this? Hit save here. Try deploying. It's just reusing it. Is this? Yeah, that's the first. Oh, here we go. Okay, I'm looking at the example contract. I need to click here to look at the staker contract. Okay, now I can read the balance for this guy, and it should be 0, right? And then I can stake. So let's put in 0.01 ETH. Okay, and hit send. Ooh, I don't have any money. I need money first. We'll go to the faucet and get some money. Now we're ready to stake. Okay, so now what we're testing here is, does our balance go up? We're supposed to have this balance that's incremented by the value. Let's go look and see if our balance went up by hitting read here. There we go, it did. Okay, so we're correctly tracking the balance. Let's hit it again and see if it adds up like it should. Yes, it does. Now it's 0.02. I don't know if that's too small. Oh, it's pretty big. You can see it. So far, we're allowing people to stake money into the contract. We see that we've collected $67 in this contract already. And we keep track of their balances. So, oh, here we go. Let's do an incognito. And let's go to this staking app. And let's grab some money from the faucet. And then let's try staking as this dude too. So let's go ahead and stake another 0.01. What I want to see here is that the money in the contract goes up, but we're tracking individual balances, and that's the key. Oh, need some money from the faucet, and then there we go. Transaction successful. Okay, so now there's even more money in the contract, right? Now it's at 0.02. Wait. Oh, I need to hit the thing. Yeah, I need to hit this dude right here, right? There we go. There we go. Now we have 0.12. There we go. So now we have $400 in the contract. And what's key here is that it's tracking the balances of the different addresses separately. So let's see what this guy's balance is. Yep, so his balance is 0.1. And this other dude's balance should be that 0.02, right? Just making sure that that's tracking and keeping track of everything right. Okay, that looks good. All right, what's next in the challenge? It seems like our stake function is at least tracking balances, right? And is that, and do you see the events? Ooh, there's events. Let's go. Stake events. Oh yeah, there we go. We can see the two events, right? Let's use the AI. Let's use this. Let's see, stake 0.5. What happens if I hit this button? So I've staked, oh yeah, it's keeping track of my individual stake. And there's that event. Okay, so it's working so far. We're able to stake and see the events, okay? Now here's where it starts talking about this smart contract being a state machine and how the timing works, right? Now what it wants us to do is set a deadline of, so the block.timestamp would be the time at which the block was mined or validated, so you can get like kind of like the current time of the chain. So we're gonna say current time plus 30 seconds, and let's see here. Let's just copy paste this. Okay, so we're gonna have a deadline of 30 seconds, And what are we going to do? We're probably going to need a require statement. Oh yeah, here's where it talks about the smart contract doesn't do anything automatic. Someone's got to poke it. Okay. Okay, so what do we need to do here? We need to have an execute function that checks if the deadline has expired. Let's just do that first. Let's just that simple function right there. So we need a function called execute. Okay, and it will be public. And what do we want to do? We want to, oh, it's trying to do something. Let's just let the AI figure it out. Let's see here. If the block dot, okay, I don't want to do that. What I do want to do, I want to write a require statement, and I want to require that the block, like the current time, we want to know that the current time is after the deadline. And let's just save that. Just straight up, that's all. I'm not going to do anything else. I just want to test this little piece of code. And this is nice with Scaffold ETH because you've got it all locally. You're on your own you're on your own blockchain. You can dink around all you want. So even though I know I need to write some more code here, I know there's more to go here, I just want to test this one thing. Does this require statement only let me execute after the deadline has passed? That's what I want to test. Okay? So if I go to debug contracts and I hit execute, time should have passed. Oh, there's one other thing you have to do here. It's kind of tricky. When you're looking at block.timestamp, there's no blocks. So when you're deploying to like a live network like Ethereum, there's blocks every 13 seconds or whatever. So this is constantly going, but on your local chain, there's no blocks happening, so we can't get the time. So just a little trick that I do is just hit this faucet button, and that basically forces a block to get mined and then gets your timestamp updated. So now if we go here and hit execute, it should just work. Yep, okay. Now let's redeploy it. Let's try this again, and I'm gonna do a -- reset. So I'm on a fresh contract. And let's see that. So there is the contract there. Let's do it again. Let's do it again. Watch for this to change. There we go. Okay, so we've got a fresh contract. Now it should fail to execute because it's not within the 30 seconds. Even if I increment this and hit this, it shouldn't. Yeah, deadline not met. Okay, cool. That was what I wanted to test. I basically wanted to test, like, does this thing keep track of time correctly, and does it only run the function once the time has passed? And it does. So we have that working. Okay, now. Okay. Yep, we're going to flip a bit in that. Okay, so if the address this, okay, so address this is going to be the address of the contract dot balance. So this tells you the balance of the smart contract. And what we want to know is it over the threshold by the deadline? Okay? So we know, and if it is, then we're going to call this code right here. And I'm just going to copy paste that. Okay, so we know we need to do some stuff in the middle of this, but there is our contract call. And this is really cool. It's going out to this other contract, and it's calling the complete function on the contract, and it's sending all of its money. Okay? So we have the staker contract, and then we have the example external contract. And the staker contract will call a function on the example contract and send all the money to it. But we need to do some stuff in the middle here. We need to do this whole this thing here. Is the contract over the threshold by the deadline? So we need to check the address.this.balance. Okay, let's do that. So we want to say, so we'll do if, I think, address balance is greater than or equal to the threshold. This would be like the positive state. Like they, oops. Oh, yeah, actually, oh, I do want that line there. There we go. So if the balance is greater than the threshold, and you can't get past this require statement if the deadline hasn't passed, right? So we know the deadline has passed, and we know that the balance is greater than the threshold. Then we're going to call this example contract complete. And if not, right? So if we're not able to get the threshold worth of ETH, we need to put it in a different mode. Thinking of our state machine, it's not a success. It's going to be kind of an open for withdraw mode, okay? So let's go ahead and, bless you. Let's go ahead and set this so else, right? If we didn't get the threshold, we're going to need to set open for withdraw to true, which means we probably need a bool up here called open for withdrawal. Yep, and it'll start out as false. Okay, so let's see what happens here. We call execute. It makes sure that the block timestamp is after the deadline, and it checks to see if we have collected enough ETH in the smart contract. And if we have, we send it to our external contract and trigger the complete. And if not, we open for withdrawals, and we let users withdraw their money back. Okay, and we want to let users withdraw. Okay, so now we need a withdraw function probably. Okay, yeah. And, whoa. And we know open for withdraw needs to be true. And what is it going to do? It's going to send the balance to the user, and then it's going to zero out the balance. Now, this should give you a little bit of goosebumps in terms of reentrancy. There's this thing that problem you can run into where you have reentrancy, where the trick, what you want to do is create a temporary variable here called amount, and then you want to zero out the amount and then transfer the money like that. And what that does is just make sure that the balance is zero by the time you call transfer, because it's called reentrancy. It's kind of like a rabbit hole to go down, but basically you could set up an attacker contract that when it receives the ETH, it actually goes back in and calls again. And what you could do is withdraw multiple times, end up draining the whole contract. Let's say there's 5 ETH in the contract and your balance is only a half an ETH. You can use that half an ETH and you can withdraw multiple times, re-entering. So kind of a weird little attack there, but that will fix it so that doesn't happen. All right, let's see if this works. So we need to, let's see, time left. Create a time left function. You want to reserve 0. Okay, let's do a time left too. That looks like a nice function to have. It's really nice that the AI just reads the comments and fills it in. Maybe we shouldn't have those comments then they're so inline. It's pretty easy to just kind of let it do its thing, huh? So what's happening here is if the timestamp is greater than the deadline, we return a 0. If not, we return deadline minus timestamp. And that should give us a report on how much time is left in the round. And so now we should be able to go here, and we see time left, right? And this won't change unless we do that thing where we cause a block to get mined. And then time left goes down. See that? Let's do it again. Okay, so it's getting there. Once that gets to 0, and by the way, I can't call execute yet, right? It's going to say something like deadline not met yet because we're waiting for this to happen. Okay, and by now, I bet we're set. Let's see, time left now goes to 0. Okay, cool. So that is doing what it needs to do. It's correctly reading how much time is left. Let's have a failure case, and then let's withdraw. Let's do that. Let's test out if we're not able to coordinate, and we put some money in there, and the time expires, can we get our money out? That's what we want to test right now. Okay, so let's just go ahead and deploy a fresh contract. All right, and then let's go ahead and stake 0.1 or something and send. And then we're just watching for this time left to be ready. Again, if I hit execute, it's going to say it's not enough time. We're waiting for this. Got to wait 13 seconds. Three seconds. Okay, here we go. It's got to be ready now. All right, so we've staked money in. We can see that there is $300 sitting in this contract. And when I call execute, it should work. And it should set open for withdraw to true, right? We weren't able to get the threshold of ETH, so it needs to put it into withdraw mode. And so open for withdraw gets set to true. And then when we call withdraw, let's try it. Hopefully we get our money back. So let's keep an eye on this and this, right? Oh, that's hard to see. What is it? 8.3? It should go to 8.4. Yeah, money's gone there, money's back here. Okay, so we've kind of tested the sad case. We staked our money and we weren't able to get enough money together from all the players, and so then we put it into that withdraw mode and we tested out and made sure that they can withdraw their money and it's not going to get stuck. But let's talk about the happy path. What we want is for a bunch of people to stake by the time the deadline happens, and then we'll hit execute and hopefully it will work. Let's try a fresh contract. Okay, and let's get another player in the game here in a little incognito window. We'll go localhost 3000, grab some money from the faucet, and go to the staker UI, and we're going to go ahead and stake 0.5 Ether. And I'm going to do the same thing over here, stake 0.5 Ether. Now there should be, you've staked 0.5 and you've staked 0.5, so we should have our total staked ETH. So now when we hit this execute, it should not put it into withdraw mode. Withdraw should stay false. Basically, it should send this money on to this other contract. Let's see what happens. Uh-oh, deadline not met. I need to do that thing. There we go. It's kind of annoying. Oh, hey, there we go. Look at that. You staked. And let's go look at contract balances. So the staker contract is empty now, and the external example contract has the 1 ETH, and the completed is true. Okay, so we were able to get the threshold together, and then by the deadline we hit execute, and it sent the money on to this contract and called this complete function. So it seems to be working pretty well. Let's see what it wants us to do now. It seems like we've tested both the happy state and the sad state, and it seems like I don't think anybody can grief us. It seems like it's pretty solid. Yeah, can you see time left? Yes. If enough ETH is staked, does it work? Yes. And if the threshold isn't met, are you able to withdraw? Yes, we've checked all of those boxes. Okay, so to improve the user experience, set the contract up so it accepts ETH. Ooh, this is cool. Okay, so we're gonna have, it's called the receive function. It's kind of like the fallback function, where if you just send money to the contract, so what we're doing is normally we're calling this function here. We're calling stake, and we're sending in money. But what they're saying is, we could set it up so you just send money directly to this address, and it will still keep track of it for you. And the way to do that is I'm just gonna let the AI do it. I don't even have to type it. Yep, I do. Yeah, I'm gonna call stake. So if someone sends money into the contract, we're gonna trigger this staking here. And it's a payable function. Okay, let's see if this works. So let's go ahead and deploy again. And what we want to do is just like YOLO some money to the contract and see what happens. So here is the contract right there. And I'm just going to go to the faucet down here, and I'm just going to send in like 0.5 ETH and hit send. So I'm not calling the function. I'm just straight up YOLOing ETH to the address, and it was successful. The money is in there, but what's interesting is it's keeping track of the balance for this user. If we go look at this user, which is the 0 user on the chain, and we check its balance, it's 0.5. So nice little piece of UX there. Instead of having to call that function, you can just give people like an ENS name, right? It could be stake.buildguild.com, and anyone can just YOLO ETH to stake.buildguild.com, and then someone still has to hit the execute button. But like I said earlier, if you figure out a way to incentivize it, you can make that work in a decentralized way. All right, use the receive function to catch. That's working. Okay, if you send ETH directly to the contract, does it update your balance? It does. Can execute get called more than once? This is an interesting one. So what if, and you really have to think about all the different edge cases, but if someone calls execute, ooh, okay, this could be really tricky. Let's say the deadline has passed, but no one has called execute yet. And there's not enough money in the contract. If someone calls execute, it would open the withdrawals. But what if someone called execute again after the balance was over the threshold? You could end up getting in a weird state where both of these things become true. So maybe we could make a variable called like has executed or something like that, and then only let them execute once. Yeah, complete. I like that. And then we'll say completed is true here. And then we'll also require not completed, right? So we require that it's not completed, and then we set completed to true. So that means that we're only ever going to go into this function once, basically. And it can't get called multiple times. There's probably like a more elegant way to do that, but it's straightforward, simple. Let's just do it that way. All right. All right. It's a trap. Make sure your funds can't get trapped in the contract. Yeah. Ooh, here's one. Try sending after you've executed. Ooh, that's tricky. Okay, let's run the whole thing and go down the happy path. Let's redeploy. Okay, and then we will just use the staker UI, and I'm just going to stake twice, and that will get us to the limit. There we've got our 1 ETH, and now we're just waiting for this time to run down. While we're doing that, let's look and see what else we need to do. Okay, yeah, it looks like we're moving on to deploy the contract, so if this works, I think we're happy. 3 seconds left, 2, 1, 0, okay. Now, what was it saying? It was saying if we send some to it, yeah. Okay, so what happens if we execute and then we send more money into the contract? So basically the staking is done, we've moved into a complete state, but that still doesn't mean that someone can't come along and send money to this contract. We basically don't want that to happen, right? We don't want money to get locked up in here. Goodness, what's happening over there? So what we want to do is probably have some other variable here. Let's see, what do we want to do? Ooh, completed. We could use completed, right? We can, in the staking function, we can require not completed. There we go. And that fixes that problem. So now, once the game is over, it makes sure no one's allowed to put any more money in. And let's go triple check this. Let's have the whole thing work, and then let's try to send some money to it, and we should get a good failure. So let's see. Grab some money from the faucet, withdraw. That's not going to work. Stake 2 times. Okay. Here we go. So now we've got our ETH, and we're just waiting for the time to tick down. Yeah, good time to retweet Damu's tweet. Good tweet, Damu. Retweet. Okay. Let's see, are we out? 0. Okay, time left. So now we execute, okay, and it puts the money into the other contract. Everything is good. Now what we want to do is make sure we can't send money to this address now. And I'll do that same thing with the faucet. I'll put in the destination, 0.1. Now this should fail. This should realize that we're completed and we don't want people to stake any money or get any money locked. Yes, already completed. Okay, cool. So I think our contract is pretty solid. We've kind of like worked through the edge cases and protected ourselves from those things. Ooh, create a modifier. Okay, hold on, let's go. Create a modifier called not completed, and it will check that the example contract is not complete. Oh, in the execute and withdraw. Okay, so we actually did that a little different. If you go through this at home, maybe you'll do it a little differently, but we kind of just wrote our own thing so it doesn't do that. It doesn't check the external contract completed, it just keeps a local state. Okay, let's deploy this thing, huh? Let's go. Let's see. So the first thing we need to do is, yeah, I'm not gonna edit the default network. I like doing just -- network. Okay, yarn generate. Should give us a deployer account, okay? And then yarn account. Should tell us about our account, and I need to send in some Sepolia. So I'll use a burner wallet, and I'll put it on Sepolia. Nope, it's loading. Internet. All right, sorry, here we go, Sepolia, and we're gonna send, yeah, I don't know. How much do I wanna send? Like $100 or something? It's Sepolia, it doesn't matter. Okay, let me scan this dude's address. All right. Okay, so we sent $100 worth of Sepolia to our deployer account, and now we can do yarn deploy -- network Sepolia. Good old test network. But yeah, this won't be as fast as like an L2. We're going to have to wait for the block to get mined. So this will be pretty slow. And I think Sepolia is pretty expensive too, isn't it? Oh no, what did I do? Not enough funds. Okay, $100 was not enough. Let's send some more. Sepolia gas is pretty crazy. Let's send $1,000. Let's send $10,000. Okay, that's definitely going to be enough. And then let's trigger the deploy again and see what happens. So we're waiting for a block to get mined on Sepolia. Oh no, no way. I mean, how much? That can't be right. How much? Let's check our account. Yarn account. How much money do we have? It seems like it shouldn't cost that much. Oh no, it's 0. Okay, what's going on here? Let me scan this dude's address again. Maybe I have this wrong. Send in 1,000 again. $7E. Okay, let's try that again. Hopefully we have a balance on Sepolia. Nope. Maybe the RPC is messed up. Let's do a different network. Okay, quick fix. I'm gonna put this out on a live network. I'm gonna pay real money. So what I want to do is adjust the threshold to 0.00001, something like that. I only want to spend like 3 cents here, right? Because this money's going to be gone forever, so I don't want to spend too much money. Yeah, this looks good. Okay, let's try deploying this to base or maybe optimism. Let's see. So we'll do yarn account again and get that account. Let's go with optimism. I did base earlier. Okay. So yeah, sending real money here. This is not the best. I'm going to send $1. That should be plenty. Because that money is gone forever. Well, this money won't be gone forever, but once we lock it up in the contract, it will be gone forever. Maybe I should just make a withdraw in here, right? Let's just make one real quick. Function. I'm just going to set it up so anybody can call it. Someone's going to steal my money. That's cool. Let's do it. All right, yarn deploy -- network optimism. All right, we're going to use the optimism L2. We're going to pay a couple cents. We're going to deploy our contract there. Instead of using a test network, because that was not working, we're going to straight up pay for it. And by the way, if you're doing this at home, go use Optimism Sepolia. I think that's what we recommend folks use. It's a test network, so you're not burning funds like I'm doing right now. Okay, we deployed our staker. All right, this thing is live. Now I want to edit that config file, right? The scaffold config where we set what network we're on. Right now we're on hard hat. If we change that over to Optimism and hit save, the whole app should now move over to Optimism. All right, here we go. Yes. Bless you. And it's going to have a switch to Optimism. And let's go ahead and stake. I don't want to stake 0.5. I got to be careful here because I could spend some real money and I don't want to do that. Let's go to the stake function and let's do 0.0001, right? I think that was the threshold. And let's send it in. What's it going to cost us? 34 cents. Not bad. Okay. So, there goes the money. It's now locked in there, right? If we hit reload, it should be sitting right there, right? There's the 34 cents. Okay, and then we're waiting for that time period to happen, right? Time left is 0. Now there should be the execute function. Let's see what happens. All right. All right. The 34 cents should disappear from here. Completed is true. Hit reload here. This should be empty. Yep. And this dude should have the 0.01 right there. And anyone in the world can call this button right now and make 34 cents. I'm going to go ahead and do it, though, before anybody else gets to it. I could even get, no, I can't get front run because it's a sequencer, a centralized sequencer. If it goes to the mempool and someone's watching the mempool and they see me put a transaction in and they can just copy my transaction and turn the gas up a little bit and front run me and steal the money. Okay, it worked. Basically, we were able to, I bet I can't turn this in on Optimism though, can I? Let's see, can I submit the challenge? Nah. So what you will do is you'll deploy your app. Whoops, I kind of want that back. You'll deploy your app, and then you'll turn it into, oh yeah, it looks like, yeah, you want to do this longer. Yep, and then we'll deploy, yep. And then it has you ship the front end. So you'll do a yarn Vercel and you'll upload the app. So once your contract is up, you need to upload your app, then you submit that here. And that is the staking challenge. Kind of a neat little simple but powerful tool or concept, powerful coordination mechanism. Okay, let's see here. Now let's go through the rest of the challenges a little bit faster. I think writing that one was nice. It was good to get in and like write some code, but let's just kind of like speed run the speed run for the rest of the time. So let's go look at these challenges. Let's go. I'm just gonna go to the GitHub. Okay. Oh. Just Scaffold ETH challenges, is it that? There we go. Okay, so let's look at challenge 2. So we've already done decentralized staker. We're going to do challenge 2 now, and this is a token vendor. So this is really cool. You're going to have one smart contract that acts as your token, and then another smart contract that you'll send the token into, and it will sell the token, a little token vendor, right? Yes, smart contracts are kind of like always-on vending machines that anyone can access. Let's make a decentralized digital currency. Then let's build an unstoppable vending machine that will buy and sell the currency. We'll learn about the approve pattern in ERC20s and how contract-to-contract interactions work. Okay, so we would basically create a token. Let's see, is that here yet? Oh no. We're just going through it. Let's not write any more code. Let's just go through it. Then you would edit the front end to display it and verify it. Okay, cool. So yeah, same thing, right? You would clone it down, you check it out, you install it, you run yarn chain, you run yarn deploy, you run yarn start, and then you have a front end that comes up, and you'll work through, can you check the balance of? Can you do a transfer? Just making sure like balance and transfer works in the token. You can send the token around. Now it's time to build the vendor, right? This will be the second contract. You're going to build a vendor.sol. So a second contract, and you'll have some exchange rate. So this is tokens per ETH, right? If you put in 1 ETH, you should get 100 tokens back. And it looks like you'll write a buy tokens function that will look at the message.value. So you'll call buy tokens and you'll send in some ETH, and it will look at the message.value and then do the calculations of tokens per ETH and then figure out how much of the token to transfer to you. So you'll send ETH in and you'll get tokens back. It looks like there's even an event that's emitted. Yep, lots of good stuff here. Pretty simple and straightforward. You're basically building a token and then selling it out of another contract. Let's see, vendor buyback. Okay, the hardest part of this challenge is to build your vendor to buy the tokens back. The reason why this is hard is because of the approve pattern. So the way ERC20s work is if this contract needs to accept the token, you don't just send the token to it. That would make a lot more sense, but that's not how it works. You basically approve this contract to take your tokens, and then you call a function on the contract and it goes and gets them. Really weird pattern. You just get used to it after a little bit, but this is going to help you kind of get over that first bump or hump. So yeah, you would have to do 2 transactions, right? So buying tokens is easy. You just YOLO some ETH in and you get some tokens back. But selling the tokens, you have to call approve on the token in 1 transaction, and then you have to call a second transaction that calls the vendor and tells the vendor, hey, I've approved this token, you can take it and do some stuff. And it will. There we go. So if you ever want to deploy a token and sell it for ETH, this is a way to do that, but only on test networks. Don't be deploying tokens on live networks, unless you really want to. Okay, so that is challenge 1. That's challenge 2. That's the token vendor. We're learning about ERC20s. We're learning about contract to contract. We're learning about that stinking approve pattern. All right, challenge 3 is a dice game. So randomness is particularly tricky on a public deterministic blockchain. Basically, the chain shows everything. So if you wanted a random number, it's hard to do in a deterministic blockchain. You can't, randomness is very hard. So a weak form of randomness is to use the previous block hash. And the problem with doing that is you can set up an attacker contract, and that's what you'll do here. So basically there's this dice game, you pay some money and you roll. If you win some money. If you lose, the money stays locked up. And so how you attack this is you build a second contract that looks at the same thing that this contract is looking at in terms of randomness to figure out, will I win or not? And basically you set it up so your dice contract, your attacker contract, only pays to roll on winning numbers, basically. So you just sit there and you call roll a bunch of times on the attacker contract, and it waits until the block hash is just right, and then it calls it and you win. So you basically only roll on winning rolls. And so that's not good, right? If you wanted real randomness, this is kind of falling apart and you can attack it, but this kind of teaches you how that works. You're gonna make a rigged contract, and you'll call this rigged roll function. And it's a really fun little challenge. I think Mr. D did the dice, pretty cool dice, like a 16-sided die. But yeah, that's the dice challenge, and that teaches you about randomness and about how to make an attacker contract that can predict the randomness, basically, or only pay if it's going to win. Okay, we're getting there. So now is the DEX. The DEX is probably one of the most important builds you will make through Speedrun Ethereum. Thinking of our token and our token vendor, we were able to mint the token and put it into the contract and let people buy it. But what if you wanted people to be able to swap, put in some tokens, get back some ETH, and you wanted the price to be variable? Well, a DEX is a really, really cool smart contract where it keeps reserves of both tokens. So it'll hold a whole bunch of your token and a whole bunch of ETH, and it will hold them at a ratio that tells you what the price is, right? So if this token was exactly 1-for-1 ETH, you would have 50% of each of the tokens in, right? But maybe the token is worth 10x the ETH, then you would have 10 ETH and 1 token in, basically. But you have these reserves, and these reserves allow you to do these swaps. And for the first time ever, you can do that in a decentralized way. You used to either have like an order book system or some kind of like centralized choke point that could fall over, but in this case, it's fully decentralized and it's all on chain. There's some bad things like impermanent loss, but that takes, you'll have to really dig in and kind of like learn all of that stuff. Maybe a good too long didn't read is that those reserves are important for making the swap work. And the more reserves you have, the cheaper the swap is, or the less slippage there is, basically. So you want to incentivize folks to be liquidity providers. So the way it works is someone puts in some ETH and some tokens, and every time there's a swap, a tiny little bit of that is left behind. And so slowly the contract actually like gains value as people are swapping back and forth because they're leaving a little bit behind, and that is to incentivize the LPs, the liquidity providers, to provide that liquidity. And this is expansive, by the way. So a really, really cool concept is the idea of a hyperstructure. Boy, I didn't get it. Structure. From Jacob from Zora. But he talks about how hyperstructures work, and they're unstoppable, they're free, they're valuable, they're expansive. This is what I was talking about, expansive. Basically, the protocol itself incentivizes people to LP. So the more money you put in, the more money you make. And that's how it's supposed to work. And therefore, if you build it correctly and you put it out there, lots of people will provide liquidity because they're financially incentivized to do so. It's permissionless, it's positive sum, it's credibly neutral. Check out hyperstructures. It's a really cool concept. Okay, so in this one, in this DEX, we'll put in some liquidity. I think you end up, let's see. Whoa. What do we do? So the structure, there's going to be like a swap function. Yeah. So you're going to be able to do ETH to token or token to ETH. And balloons are our token. Yeah, and here are the reserves, right? You have to, so there's a function to swap, but there's also a function to put money in or a function to pull money out in terms of liquidity. Yeah, and you also need to initialize it with some initial liquidity, and that kind of sets the starting price. And yeah, here's this. This is the very popular, what happens here is so this is the old position and this is the new position. You put in token A and you get out token B. And you can see by this curve, the farther you go this way, the more slippage there is. So the more reserves you have, the smaller that little chunk is. But yeah, go take on the DEX challenge. There's a lot of intricacies here that I'm not really getting into. This like constant product thing. There's a lot of great stuff to learn here. Go do this on your own sometime. Go through the DEX, and you'll learn a lot. And it's really like one of the neatest contracts. Let's see, liquidity we already kind of know about. Let's see if there's anything else here before. Oh, here, does this show the swap? Yeah, so it's going to kind of give you a little drawing for when tokens go in and what comes out. Yep, and then you deploy it live, and you verify it, and you turn it in. And our auto grader will go swap some tokens on your DEX and make sure everything works right. Looks like there's even like a YouTube video here. I wonder what that one is. Okay, so those are the most important challenges. Everything else from here is like dessert, basically. Challenge 4, taking on the DEX, is like the challenge. If you can build a DEX, you can build a lot of different things. Like this is a good like, am I ready yet kind of test. Like, can you sit down and build a DEX? Okay, there's 3 more challenges here. There's a state channels application. This is really cool because it uses signatures. You don't always have to put everything on chain. Sometimes you can do things between parties with just signatures, and sometimes you can even have like a smart contract that those signatures settle to. And in this one, you kind of learn about state channels and about kind of like how scaling could work or does work. And then I think is multisig next. Let's see what's next. Yep, multisig. So multisig is a really cool. Let's go look at this. Let's go look at this code. So a multisig is a smart contract, and you can send money into the smart contract, and multiple people need to sign to make that money send out, basically, right? You have to get like 3 out of 5 signatures. Let's go see what the code looks like. Yeah, there we go. And then if we look at some function here, yeah, so you're going to keep track of signers. You can add and remove signers. There, execute transaction. This is really interesting. Let's look at this function here. So you pass in some to address and some value and some data and the signatures, and then it actually goes through and validates the signatures. And then if everything is valid and you have enough valid signatures, right, you'll need to have valid signatures needs to be greater than or equal to signatures required. And if so, you can call the function. It actually executes whatever you want it to. Just some arbitrary call data gets executed there. And that's a multisig. Really, really cool little multisig, really handy, especially for storing large amounts of money, like a DAO has a treasury. So like a multisig is like a Gnosis safe. If you don't have a Gnosis safe yet, you should go get one. Gnosis safe. It's a great way to hold your money in an account where it takes multiple signers basically to move that money around. So it's just a lot safer. Let's say you have 3 accounts and one of them leaks. you can just remove that leaked account and then put a new account in. Whereas if that leaked account had money on it, the money's gone forever, right? So the multi-sig is a nice way to kind of safely hold your funds. Here, yeah, it's an ECDSA. Let me find it. There's a function called recover right here. So what this function does, do you see that? Is that big enough? So it's, so you can sign any arbitrary message. So Austin likes beer. I sign that message, and then I send it in here, and I take the thing I signed, which would be, in this case, is just a hash, but it could be like a string. I think this is a hash of a string. And then the signatures. So with the message that they signed and their signature, you can do a recover, and it will give you back the person who signed it. And this is a really powerful tool for a lot of things, but doing ECDSA recovery in Solidity is really nice. Like, it leads to things like meta transactions and all sorts of other cool things you can do. Does that make sense? Did that answer it? Cool. Okay, all the way to the bottom, SVG NFT. This is kind of like the ending challenge. Uh-oh. What did I do here? This is kind of the last challenge. You're supposed to make an NFT, just like those NFTs that we did at the beginning where we were minting the little buffalo and the zebra. Those were going to IPFS, though. When you minted those, the image is actually stored on IPFS, and it's like the hash of the image is stored in the smart contract. So it's kind of like not as cool. With an SVG NFT, you actually put the contents, like how to draw it. Like if you go look at an SVG, it just looks like some code. But you put all of that code right into the contract, and then the contract itself can render the SVG. Pretty cool little challenge. Yeah, you make some loogies, I think. Optimistic loogies, is that what they are? Classic. But that is the last challenge, and I would recommend y'all going through this on your own time at home. You can go to the Scaffold ETH repo and find Scaffold ETH 2 challenges, or just go to speedrunethereum.com. And I think that's mostly what I have to present, but maybe open it up for questions. If anybody has questions about anything or concerns or anything, I'm all ears. Yeah.
What about, can I do some like PR to add some more challenges? Because, for example, I work with Snarks, a Snark compiler, so maybe an example for verifying Snark or like extending something is...
So you're saying, could you PR into Scaffold ETH some new challenges? Possibly. I mean, that state channels was actually made by someone else and they PR'd it in, so it's possible, but it's more likely that you just like fork Speedrun Ethereum and make Speedrun Starkware or something. I think actually someone did that exact thing. Let me see. Did you say Starkware? Oh, Snarks, I see. Yeah, there is Scaffold. Yeah, so maybe you want to do some ZK stuff or something like that. Yep. Speaking of that, let's go to, if you go to buildguild.com, Biddle, and you go down to the bottom, there's this Miro board. There's this tech tree link right here. It's kind of buried. But it has all sorts of other challenges beyond just the speedrun challenges, all sorts of things that you can build on chain. And yeah, there's like a whole section here on zero knowledge. Oh man, how do I move? No. Dang it. Oh, there we go. That'll work. Okay. So yeah, you can do like this just like covers like all these different concepts within the space and how to just like test your knowledge and build things. There's like a little Circon starter kit, and the guys who made Dark Forest are actually here. They're the frog guys. The guys with the frog hats actually made this game Dark Forest. It's like one of the coolest games ever made on chain. Using ZK snarks or ZK tech in some way. Okay, I think I'm about done, but definitely open for more questions if anybody has any questions. Go speedrun Ethereum. That's the important thing. Yes.
Yes.
This is a beginner session. I think I'm going to ask a very, very dumb question, if you don't mind. I'm a very beginner. I was trying to understand more on the storing on chain and how to use that instead of utilizing any databases, using chain as a database. Like, how does it work, and which parts actually is advised to store on chain, which parts not, or how? That's
This is a kind of a moving target because, you know, a few years ago I would say you're making a mistake if you're storing lots of stuff. If you're using it like a database, you're making a mistake. It's not meant to be a database. It's a very expensive, slow, asynchronous database, right? But the needle has moved, and L2s now exist, and L2s are super cheap. Maybe it starts to make sense to actually start using them like a database again. I think you have to be careful because this is all public, right? Like everything that goes in there is going to be visible to everyone. So if it's like medical records or something like that, it's all like, no way can you do that, right? Or like anything that could dox someone, like connecting an account to an address and someone shows up at your house with a wrench. Like there's a lot of things that you don't want to put on chain just for like privacy concerns. But you can store strings, you can store numbers. It works kind of like a database. And on an L2, it's a lot cheaper with blobs. Blobs are going to get a little bit more expensive, so it will get a little more expensive, I think. But I think they're trying to push it cheaper and cheaper, too.
But
does that sort of make sense?
It does make sense, but again, like, so I should not really treat blockchain as a database, or can I?
I think you can, yes. Like, if you wanted to make Uber on chain, you would have a very hard time, right? That's like a constant thing we see at hackathons. It's just not very practical. Oh, no, what do they do? But maybe there is other places where you could use it like a database and it makes sense. I think it comes down to the application and how sensitive the data is and how much you're willing to store, like pay to store it. But thanks to L2s, I think, yes, you can use it like a database again.
Thanks.
More questions? Yes.
Okay, thank you. On challenge 0, you said that the image, the zebra image, was stored on IPFS.
It was on IPFS. Here, let's see, is it still up? The image, okay, so what happens is you have a manifest, which is like your name and your image link, and it's like a JSON object. And then inside of that was an image link, and that's what we're using to render. That goes into IPFS, and you get a hash back. And so it's not stored on chain. Like the image itself is not stored on chain. It's the hash of the image that's stored on chain. So you go to the blockchain and you get the hash, and then you take that hash to IPFS and get the information back. But it's not stored on chain. It's stored in IPFS. Does that make sense? It's just like the hash that goes on chain. Yeah.
Okay, yes. I would like to know, to understand the interaction, because when you hit on the mint button, yes, it means an NFT.
Yeah.
Now, I would like to know where does the interaction between the contract and the IPFS is located. So at which level is this interaction? So do I need, if I want to implement it in my code, do I need to get such an API key to drop my image on the IPFS?
No. Okay, so IPFS is like a distributed storage system. And what happens is you go look up content. It's content addressable. So like an image goes into IPFS. It's not like going to the cloud somewhere. It's going to some machine somewhere, right? So you actually have to run an IPFS node, and you have to pin your images on that node to keep them to stay there. So if you can add things, you can upload things to IPFS, but have no guarantees that that thing will stay in IPFS. So you end up having to run your own pinner usually, which is just like an IPFS node that you add files to. I still don't know if I'm fully answering your question. Like, so, yeah, maybe you could ask. Yeah, how am I answering your question? Yeah.
Yes, I think you'll go. I have another question on the second, the challenge number 1. Yes, you implemented a protection against a reentrancy attack.
Yeah.
Yes, I read somewhere that the send function is subject to a limitation, a gas limit of 2,300.
I'm sorry, I didn't understand you. Something about reentrancy.
Yes, when this is something I read. I don't know if so when you use send to send ether or to send ether to another address.
Yeah.
Yes, it is subject to a limitation of 2,300 gas.
Yes. When you do a dot send, here, the best place to look this up is go to Solidity by example. And there's a really good example here about sending ETH. Where is that? Right here, sending Ether. And this explains it really well. This 2,300 gas you're talking about. If you use transfer or you use send, it basically locks it at this much gas. And so if you want some other execution to happen on the other end of that transfer, say you're transferring to a smart contract and it executes some other stuff, you will run out of gas. So what you need to do is do a dot call instead. So the way you send ETH looks like, where is the dot call? I didn't even see it there. Oh, here it is. Yeah, here it is. So you do toAddress dot call, and then you send the value in. So really weird kind of thing. It looks like you're like calling a function on this contract, but you're just sending money in. But that's the way you do it if you want to forward along all your gas. Like if it needs to do a bunch of execution on when it receives that and needs to spend some gas, you'll want to use dot call instead of dot send or dot transfer.
Okay. So at this moment, when I use dot call, I should now implement reentrancy protection.
It depends on the application. Like you need the reentrancy stuff is kind of different than this stuff. This is just like how to send stuff. You need to implement reentrancy protection if someone can reenter your app and like attack it. Like what we did to mitigate it was create a variable and store the balance into the variable and then zero out the balance and then send the money. So by the time the money gets to them, their balance is already zero and they can't re-enter. So it doesn't have anything to do with how we're calling send or transfer. It's everything to do with how the code is structured and if it's structured in a way that is vulnerable to reentrancy.
Okay, thank you.
Yep. Any last questions? Thank you for the Build Guild coming out to support me. You guys, it's probably pretty boring listening to this talk. We got 4 more hours of it tomorrow, too. All right, thank you all. Thanks for having me. Go speedrun Ethereum.
What AI do you use for the codes? That was very good to find a solution.
The AI? Yeah, it's Cursor.
Which one?
Cursor.
Cursor, yes.
C-U-R-S-O-R, I think.
Cursor, okay. Okay, that was great.
Yeah, if you're not using GPT every day, you should be, for sure. Copilot is one thing, but this is actually like, we'll go to the cloud.